Tomorrow, just let me know when we're live. Cool. Well, more folks are going to trickle in because everybody comes in late once the talks actually start. I feel like we're doing almost like a mini movie screening, but it's just code. But thanks everybody for attending. This is going to be our second iteration of the Hackerhouse. If anybody here was from the last one, we did one in Berlin for Euler. Super cool. Everybody had a good time. This is probably the best chance that you'll have to get a very solid overview of V4. And additionally, any subsequent projects or protocols or primitives that start to build using V4. As an auditor, as a researcher, this is a great opportunity for you just to get a head start, as well as obviously compete in the competition itself. So we have 2.35 million, I think, is the total pot. What I'm going to do is just do a quick walkthrough of the pending schedule. So breakfast will still be available, I believe, right now if you want to hop in and grab something real quick. I think everybody here is more or less eaten. Right now, we're just doing a quick intros and a welcome to everybody to coming to the Hackerhouse, our first one in New York. We'll start off things with the code walkthrough from Alice and Sarah from Uniswap. We'll hit lunch around 12:15. We'll do an attack surface overview / threat modeling session with Alice as well. Certora is here, or the great folks from Certora will hit the FV piece around 1:30, and then we'll have a very interesting panel. So we'll have some of the best researchers and auditors who have already reviewed V4, some folks including Kurt Berry, and some other folks we'll showcase in a second. And then we'll have a working session. What that means essentially is that if you want to chat with the team, if you want to audit the competition live, you have full access to the Uniswap team. So we highly recommend taking advantage of it. Or if you're working on something else, feel free to network and work on whatever you'd like. And then at 5, we'll kick off with a light dinner and you're free to go. But yeah, without further ado, I'd like to invite up Alice from Uniswap, and we'll go ahead and kick off the walkthrough. Just as a quick notice, we are live streaming this. If you don't want to appear in any media content or anything, just tell Samara. She's like right there, back left or back right. She will make sure that we scrub you out of anything if you're in like your employer doesn't like it for whatever reason. That's your problem, but we recommend figuring a different employer. Anyways. Without further ado, Alice and Sarah from Uniswap, please give them a round of applause and we'll dive in.
Yeah, it should work. We can dream. Hello, everybody.
Can we put this next?
Oh, yeah.
Yeah. Hello, friends.
Should we do a little introduction?
Yeah.
We're very excited that everybody's here. We can't believe so many people are coming today.
Out of curiosity, how many people flew in from out of town?
Damn.
Okay.
Big commitment.
Wow. Cool. Well, it's nice to have you guys. Yeah, let's do quick intros.
Yeah.
I'm Sarah. I'm one of the protocol engineers, and I've been working on V4 for probably,
Too long?
Yeah, too long. I think a year and a half, maybe even more. And Alice?
Yeah, I'm Alice. I am also one of the protocol engineers, been working on V4 just as long, really. We've both been at Uniswap about 3 years now.
Yeah.
And today is really all about you guys. Like, we're here to give you content, but we want to make it as valuable as possible to enable people to, I guess, hopefully find bugs, but we're hoping that you don't. But if there are bugs, we'd love you to find them. So if at any point you have a question, just put your hand up. We want to make it interactive and valuable. Yes?
Can you guys show us your GitHub IDs as well?
Yes.
We saw avatars, faces, but we don't know how to associate them with your people.
Oh, interesting.
Oh, that's a good question. Yeah, why don't you pull it up right now? I feel like both of ours are.
You can see that
our faces.
my most
actually.
visited.
Okay,
My most
we'll
visited.
pull it up.
So this is me. Henshaw 256. You need it more zoomed in? I don't know. Can you see it here? And Sarah, what's yours?
You could just go to the repo, probably.
Yeah.
Right?
We'll get a V4. Find you. Oh.
Contributors.
Are we top 2?
I don't know.
What do we think?
There's so many, probably lots
There's
of
a lot of
V3.
contributors.
Yeah.
Okay. This is taking a second. It'll be there soon though. And we're going to start the day with a code walkthrough. We'll walk through core, the architecture, some bits of code, some interesting features, and then Source over there is he's from Uniswap Foundation. He's gonna come and walk through, why is this not working? He's gonna come and walk through,
Oh, there we go.
here she is. He's gonna come and walk through the position manager, which is the contract that allows people to add and remove liquidity from V4. And we'll walk through the router that routes our swaps on chain, and finally migration. So a little bit of code we have to allow people to easily migrate funds from V3 to V4 in a single transaction. So I guess we should get started.
Yeah. Again, please feel free to stop us as we walk through, because we have a ton of context. We're not really sure what you guys don't know, what you already know. So if we're going too slow, too fast, just wave us, flag us down.
Is this zoomed in enough? More? One more?
Okay.
Look at that beautiful V4 unicorn.
I love it. I like the possum better. Okay, so just before we dive into the code, I think I'll just get a quick sense of how many of you guys have read the code for core or pieces of it. Okay, it's about less than half the room. Cool. How many of you guys are familiar with Uniswap v3 code? Okay, all right, cool. Well, before we dive right into the code then, let me just give a high level sort of pitch for V4 and kind of where we've come from. As I'm sure most of you know, Uniswap v3 was a concentrated AMM. V4 operates on this same liquidity model. So it's a concentrated liquidity AMM. So all of the same math that you saw in V3 is pretty much, I would say, the same in V4. And really what V4 innovates on is the expressiveness in terms of what a pool can do, because we now have hooks. So I'm sure you guys have also heard of hooks, but I like to explain them as sort of these entry points that you can sort of execute arbitrary logic during certain predefined life cycles of a pool. So for example, we have the before and after swap hook call sites, and these just will inject code essentially throughout points of a swap, or points in modify liquidity, etc. And so I think what's really cool about this feature, and something that we were really excited about when we built V4, was the potential for really quick innovation with AMMs, because you can leverage the entire security model of Uniswap v4, but also be able to kind of experiment really fast by writing your own specific code and attaching them to pools that also not, you leverage the security model, but you also leverage some of the other liquidity, because we're operating on a singleton style contract, which I'll talk a little bit about in a second. So that's sort of the high level, I think, motivation for V4 and for what we're excited to see the community build on with V4. I'll pause here. Any questions? Okay, cool. Let's get into the code. Okay. So this is going to be our main contract. This is poolmanager.sol. This is the basically essential entry point contract, and normally what we refer to as the singleton. Oh my gosh, sorry, the screen is huge.
Yeah, it's very zoomed in.
Yeah, very zoomed in. So in V3, we had a model where every pool was its own contract. In V4, that's no longer the case. What you'll see, where is our pools mapping? Where is it, guys? I can't, here we go. Okay, so this is the pools mapping. You can see that it's a map from the pool ID to pool state. So this means that every pool, every storage slot, anything relating to information about a pool is held in this one contract. And that's why we call it the singleton, which is pretty powerful. It's also pretty scary, because that means that all of the assets held by V4 is in one contract, right? And so I think the key thing to call out here is, one of the reasons to do this was gas. So this makes it more efficient when routing from pool to pool. In V3, if you want to route from, say like ETH USDC, USDC DAI, you have to do transfers in and out of those two contracts. When we're operating in V4, all of those assets are held in one contract. And so you get this really nice property of only being able to transfer in and out the ending currencies. So the first token in and the last token out, and all of the intermediate currencies in between are essentially, canceled out. And we refer to this accounting system as flash accounting. So I know I'm throwing a lot of words at you, but we'll go into what that looks like in a bit. Any questions about singleton model and kind of benefits of singleton? Questions about what a pool ID is? Okay, well, I think that's pretty important. So let's look at pool ID, or pool key. So every pool is uniquely identified by these 5 properties. So the 2 currencies, currency 0, currency 1, the fee, which unlike V3 can be basically anything, tick spacing, and then hooks. Hooks is just an address. So really you have kind of unlimited possibilities for pools. And you'll notice that there's probably going to be, or there could be, an infinite number of pools with the same currencies, which is interesting. One of the things, we were worried about was, okay, like, does that mean there's going to be higher fragmentation of liquidity? But actually, one of the reasons to go with singleton model is to then reduce that fragmentation. So there's less, negative effects of fragmentation when all of the liquidity is still held in one contract. Cool. So pool ID is then a hash of all of these 5 variables. And when you initialize a pool, you set the pool ID to, So when you initialize a pool, you're going to pass in all of the information related to the pool key, the starting price, any hook data, and you're going to set the, this inside of pool. You're going to actually set the pool information. So hash the pool key and then set the pool the initial pool state on initialize.
Yeah.
Yes.
So you said that the structure of one contract enables to have a lot of pools, but they're all together, like preventing some kind of fragmentation of liquidity. But that is, if I understand you correctly, that is in terms of transaction-wise, I can work through many different pools and it counts as one transaction. What about information-wise? I mean, if how do I know what are the pools that are out there? I mean, there's a lot of things to be said on that, but is there anything in the contract that puts the information in one place?
No.
No. Yeah, there's not. Yeah.
Yeah, exactly. There is an initialize event, so this is where the data for this will be found. So this initialize event emits the ID, which is the hash of that pool key, so you always have that, and then all of the information about the initial state of that pool. And there's going to be a large reliance on indexing services. We considered putting a mapping on chain of pool ID to pool key, but it doubled the cost of creating a new pool. And you still then, for V3, it was possible to enumerate all the possible pools. If you had two assets, you knew that there's 4 possible fee tiers. And so you could just check, does this one exist? Does this one exist? And check the 4, and you know all the possible V3 pools. For V4, you can't pre-predict what fee, tick spacing, and hook combinations people are going to go with. So even if you had that mapping, you wouldn't be able to enumerate it on chain anyway. So it felt like,
Basically, you have to emit an
yeah,
event.
it was going to be
Yeah.
better to figure that out off chain, which is a shame for some on chain contracts, but right. Yeah. So that's what has to be done off chain largely through this initialize event. This initialize event is, I think in V3 you said it was called the pool created event. It's the same concept. It's just called initialize. And this is the creation of a new pool. But on chain you can't query that a new pool was just created.
Right. So you could have some kind of indexing service. You could rely on the subgraph. So some of our team is creating like a V4 subgraph. And so you'll be able to ingest these events, process them. I don't think we have it right now. I think it's being built or worked on. Do you know?
I don't know if it's finished.
Yeah.
Good question.
Not sure if it's finished, but it will all be public. Yeah.
And
Yeah,
if it's not finished, it's very nearly finished. We're working on all these things at the moment. And yeah, it'll be public for people to use. Nice.
One last question.
Yeah.
It's just this pool information written on a storage, the square root of price and
Yes.
it's not very convenient to access. So can we at some point have, for hooks, can we have a library that would give us access to all of these parameters?
Like
Yes.
this library. So for each, you're talking about because it's inconvenient because of the external S load function?
Oh yeah, this is what I'm talking.
Yeah.
You're welcome. No, but it is confusing. So I mean, we'll jump to a random topic.
Yeah.
Oh,
I
where
feel
is
like
it?
it's
Oh,
worth
it's in
talking.
And thank you for the mic.
external.
Oh,
Oh, you're welcome. So yeah, because there's so much state stored in this contract, there's so many possible variables to look up. There's potentially infinite pools. Each one has so much information stored about it. There's so many storage slots you might want to access, and instead of providing a getter for each one where you call get liquidity for this pool, get current price for this pool, we've exposed 2 different functions called external S load, which allows you to specify any storage slot and it will return to you the value that's stored in that storage slot, which obviously isn't the nicest thing to integrate with, which is I think what you were saying. How do you know which storage slot something's stored in? So this means the core code only has to have these 2 getters, which saved us a lot of bytecode to then use on nice features. And so this library can be used, and it basically translates nice getter names like get slot 0, which is a name that's similar to something in V3, which you pass in the pool ID and it will tell you the price and the tick and the protocol fee and the LP fee for a pool. And it translates that behind the scenes into what should be passed into external S load so that you don't have to figure that out yourself. And this library is full of functions.
Like anything for positions, you can get, I think it's basically any storage.
Yeah, to try and make it easier to look these things up. Right.
Cool. Okay.
Unlocking model, I
Yes.
guess.
Okay. So I would say the whole of V4, I think security is really held in these couple of lines, which is kind of cool, kind of scary. So we have this mechanism called unlock. Unlock, all it really does is performs an unlock callback on the message sender. That means that essentially the contract is set in this unlock state, and any external function inside Pool Manager that's defined with this only when unlocked modifier. So that's basically modify liquidity, that's swap. It's essentially any function that may apply a delta, which we'll talk about in a second, must be called within this sort of unlock state. And the reason this is safe is because at the very end of unlock, after the caller has performed any number of actions on core, we have this check right here, line 110, which just says, is the non-zero delta count 0? If it's not 0, we have to revert. And so that, it might take a little bit to break down what that means, but the accounting mechanism in core operates on what we call deltas, which are just positive and negative balances of tokens. And so as you're going through and performing these actions, if you owe something to the pool, you'll be in debt to the pool. So you'll accrue a negative delta. If the pool owes you something, you will be credited a delta. And so we have this function here, account delta, that's called within a lot of these functions in core that performs this logic of adding or subtracting deltas to the caller. With this functionality, we also have this variable here, non-zero delta count, which just counts the number of deltas that are essentially open, that are not 0. So if you have positive delta of 10 in USDC, and then you perform an action that where you pay 10, where you take 10, that means you would apply a negative delta, and your delta would now cancel out and be 0, and you would hit this code where you say non-zero delta count decrement. And so as basically the entire unlocking mechanism is secure because we check that at the very end of unlock, all of the deltas that have been opened or closed on core are canceled out.
A lot like flash loans, but a crazy flash loan.
Yeah. Cool.
Yeah, if this line is broken, that's it for V4. So I guess start there.
I'd also say if there's any function that calls account delta is going to be a really core function. If there are any assumptions broken before the account delta function is called, that's like critical. Cool. Maybe really quickly, I want to talk about some of our use of transient storage.
Yeah, we could go through each of them.
Yeah.
So do people know what transient storage is? Yeah, some people know. We can go through it from basics. So storage in a smart contract is, we used to have essentially memory and storage. Memory inside a function, the little variables that you use within a function to keep track of things, like this is in memory because it's just used within the initialize function. And then you've got storage, which is state that's persisted between transactions, so you can put it globally in the contract, and you'd use that for who has an LP position. Well, you don't want that to disappear at the end of a transaction, so you put that in storage, and it's kept in the contract forever, and it can be updated in transactions, but then it's persisted between transactions. And for a long time, it was essentially just those two, and call data, I guess, but we won't get into that. And someone came up with this idea of transient storage, which is, what if you want a global state for a contract that persists for more than just a function call, but you don't need it outside of the transaction? So this would mean lots of different calls could go in and out between different contracts, and there's some state that is permanent between all of those calls, but at the end of the transaction, it's gone again. And we use transient storage a fair amount in V4. The main things we could talk about, the things that we've already mentioned, is so this lock. We have a call here, so the lock, whether or not the contract is locked, can't be in memory, but it doesn't need to be in storage because the lock only lasts the duration of a transaction. And so that lock can be in transient storage, so it lasts the entire length of the transaction, but it's gone again afterwards. Unfortunately, transient storage for now can only be accessed through assembly. I think they're bringing in they're bringing in the word transient, I think, pretty soon, but it's too late for us. So we have to access it in storage, which is why lots of our calls look like this. Instead of here just writing like lock equals true, we have to put it inside a library so that we can abstract that away. So if we go into the lock, well, that's weird. Yeah, it's that one. Strange. So we just have, it looks kind of ugly, but it just essentially says the function unlock does a transient store into our locker slot of true. And so that's essentially the same of like is unlocked equals true, but in a transient variable. And then we have various functions that operate over this is unlocked storage slot so that you can read it, you can write to it, and set different states. And we've defined which slot of transient storage that should be here.
And we pretty much use this same sort of pattern when we work with transient storage anywhere. So if you want to go to the non-zero delta count library, so similar style of code where we're just reading and writing with tstore tload on like a predefined slot. So here we have the non-zero delta count slot.
Yeah. And it increment just does exactly what you'd expect. It's like x equals x plus 1, decrement the same. It just looks more complicated because we had to use assembly here. Yes. Yes, I would.
Yeah.
I mean, if you find a bug in that, we would be concerned.
Yes.
I don't
know if
we'd have to speak to managers.
Yeah.
But I mean, yeah, if there's a bug in transient storage, for sure we'd want to know. I guess we'd consider paying out for that. I hope there's not. Yeah, I'd have to run that past some people, but what else do we, so non-zero delta count is just that incrementing and decrementing of deltas, and where do we store the deltas? We have another transient storage library that is essentially a mapping. So the other ones were just essentially global variables. This is essentially a mapping, but again, we have to do it in assembly, so it's a mapping that looks something like mapping of what's the currency, what's the address that's called the function and therefore is owed/owes money. This is not the syntax for a mapping. And then, sorry, this is pseudocode. And then it gives you an integer of, is that a debt? How much money is owed or not owed to the contract? And so we essentially implement that, but in transient storage in this library. So there's get delta, which looks them up, and there's apply delta, which looks it up, but then adds or subtracts this from that delta to keep track of who owes what money. And every time we apply a delta, obviously we then increment or decrement the non-zero delta count if it has changed that state.
And I would say this is probably the biggest benefit to using transient storage in v4, because you can imagine if all of the functions are operating on writing to and from this delta space, if all of this was in storage, it would get pretty expensive every time.
Do we have any other transient storage? I'm trying to remember.
Reserves.
Oh.
Currency
Yes.
reserves.
Yes. Oh, we'll get into this later.
Code.
I feel like we should talk about this later.
Yeah.
You need a lot of context
We'll
for
get
this
to
one.
that in a bit.
Okay.
Cool. Maybe, do you want to go through? Well, is there any questions? Yes.
So taking the hash legacy point, is there a convention for that? Where did it come from? I'm just curious from
I think we got it from an EIP.
1967?
Don't we have it?
The -1 from a storage slot, 1967, I think. Might not be.
I forget the number.
1967?
Okay.
Okay.
Did we write it? Oh, we didn't.
No, we
comment
didn't.
it. Oop. Okay.
Oops. It's normally for, I think it was originally created for proxy contracts when you're forwarding calls and you don't want to have collisions of storage slots. And the reason you subtract 1 is just it's pre-hash resistant, pre-image resistant. Yeah. Right. Yeah, so you decrease the risk of someone being able to overwrite your slot that you were wanting to keep secure. Obviously, we don't think that's possible anyway, but this way no one has any way of finding the pre-image of that hash just because you subtract 1.
And it's nice to follow the EIP.
Yeah.
Sorry, somebody else had a
Oh, yeah.
question. Yes.
Yeah. That is not the case anymore. We did consider that. Essentially, like, it would still be secure for it to track only the debts to the pool and just say, well, if you transfer in too much money, that's your fault, essentially. We wanted to, some people end up losing a fair amount of money that way because they don't realize they've sent in a whole ETH too much or something, and it doesn't flag that to them. And so it still reverts if you don't do that, but we have a function called, obviously so first of all, to withdraw funds, you use the function take, and you say, I want to take out this much money, and it transfers it to you. But if the cost of that transfer is more than maybe you've just got a little bit of dust in the contract, 3-way or something, and it would revert if you don't take it, and that's really annoying. And calling take is going to transfer it to you, but the price you're going to pay in gas to withdraw those 3-way is going to be more than the actual amount of way. So most people wouldn't want to. So for that exact situation, we have a function called clear, which essentially allows people to leave money in the contract. It clears their delta. So if you have a positive delta of 3-way, you could just call clear and it won't transfer it to you. We decided to put this in as a function to protect people, basically. You have to knowingly have sent in too much money and say that you don't want that money to leave it in there. And you have to pass in the amount. So if you know you have 3-way too much that you've left in there, you pass in the amount 3-way and it'll clear that delta for you. But it was to prevent people from leaving accidentally $20,000 in the contract. You can still do that with clear, but you have to purposefully leave it in there.
And yeah, that's not recoverable. So
Like
it's locked forever.
Any other questions? Nice.
Should we do custom types?
Custom types. Nice. So I feel like custom types aren't that widely used. Maybe they're getting a bit more traction now. It's essentially this mechanism, it's newer mechanism in Solidity that you can give a name to a pre-existing type so that it's easier to read your code. So here we define type balance delta is int 256. So whenever you see the term balance delta, it's behind the scenes an int 256. And we use it, as it says up here, it's 2 packed int 128 values in one slot. And why do we use that? Well, every action you perform on a pool, so let's say you're swapping, there's 2 currencies involved. One that's going in and one that's going out. So you need a delta of 2 different currencies. You add liquidity, you've got, again, 2 currencies that you need a delta in. And so we were always having to pass around 2 deltas together in a lot of places. And so it made sense to have this one type called balance delta that passes around 2 deltas for a pool. And then on this line, so down here, again, bit of assembly, but we essentially define what does it mean to add 2 balance deltas together. Well, it just extracts the amount of currency 0, the amount of currency 1 from each of them, adds the zeros together, adds the ones together, and packs them back into a balance delta type. And you don't want to write that all over the code. So in this library, we have an add function, a subtract function. We define what it means for 2 balance deltas to be equal, to not be equal. Here's the functions to extract 1/2 of the delta. So you could do balance delta dot amount 0, and it'll give you whatever that delta is. And then up here, we use a fairly new global keyword, which says every time we write balance delta 1 plus balance delta, spelled that wrong, 2, behind the scenes, it's doing .add. So we can still write code that looks like you're just adding 2 things together, but because of this line up here, it's enabling us to use the plus. So balance deltas are these 2 numbers stuck together to track the deltas in 2 currencies for a pool. What other custom types? We have pool ID, which we talked about earlier, is a custom type. It's just a hash, so it's a bytes 32, but it's really nice in the code to be able to see that this is a pool ID. It's not just some random bytes 32 where you have to go and figure out what it is.
We also, I think, oh,
Yeah.
yes.
That line, is it considered a separate type in terms of compiling, like the type verification? If I do like what you did there, the balance as a integer. I mean, when like if and then I do like something that is a balance plus 5, which is just an integer, would that be an error?
Yeah, it would be
Yeah.
an error.
Consider a separate type?
Yeah.
Yes.
It has to be 2 balance deltas,
Or
and then
you
it knows
can-
what plus means.
Or you can call like balance delta dot unwrap, and so then it'll treat it like its underlying type in int 256.
Oh, yeah.
I'm
You
sure
can
we could
see it in this
here.
function. If you do, if you
dot
have a balance
unwrap.
delta and you do unwrap, that unwraps it into an integer in 256.
Okay, and there's no implicit casting or anything like that.
No.
I'm just
Yeah.
struggling with exactly that point for.
Yeah,
and
you can't cat. I mean, you just have to call unwrap.
And wrap as well.
And if I do an unwrap on something like integer, then it will just leave you with the same type, or it will throw an error.
You can't. You have to unwrap a balance delta into what it's
Yeah, I know
hidden.
if I by mistake try to unwrap something that is.
Oh, it
I
won't.
think it would.
It won't
throw an
unwrap.
error.
You want to wrap, meaning there will be an error.
I think there would be an error, but I'm not sure.
Number, give me the same type.
It would be an
I
error.
think it'd be an error.
So then our other main type, custom type, is currency. In V3, it just supported ERC20 tokens, so we'd pass around ERC20s everywhere. In V4, the native currency is supported again, and so for any currency, it might be an ERC20 or it might be the native currency. And so we've again got this type currency, which is an address, which is often an ERC20 token, but we also have the 0 address to represent the native currency on any chain. And then this library, using the currency type, allows us to define something like a transfer function, where the rest of the code doesn't need to know, is this ETH or is this an ERC20, because they get transferred in different ways. Within here, within the library hidden, it says, is this the native currency, and do a transfer in one type of way. Otherwise, it's an ERC20 and do a transfer in the other kind of way. So this custom type currency allows us to abstract away that idea as well.
In currency delta line 16.
Yes.
So.
Oh, currency delta.
Yes. It's just a compiler question. Oh, not here. You had a constant in one of these custom types.
Oh, my current. Maybe it's just
in here somewhere.
No, in the first one you showed. Sorry. Balance.
Line 16.
Yes. So when is that sub shift left 128 is calculated? Is it at the runtime or is it at the run? Oh, okay. So it would be more efficient if you actually write the literal, the output there, right?
But we don't know what amount 0 is until runtime.
No, the next one.
Oh, the optimizer handles that. Yeah, so this could be written as a hard-coded value, but it's much easier to see what this value is. So it would be like OXFFFFFFFF, and you lose count of how many you've written, and then you easily write 1 too few or 1 too many. This value, with enough optimizer runs of the compiler, it predetermines its value and inserts that instead. So we find it easier to read like this, but because our optimizer runs are lots of 4s, because it's Uniswap v4, it replaces that. We've tested lots of these things.
ABDK has been complaining about it. That got me confused. I had the same.
It all depends on your optimizer runs. If you have 0 optimizer runs, ABDK are correct. With our number of optimizer runs, it no longer applies, which is why we haven't fixed those issues.
I see. One other question, sir. In the currency library.
Yes. Yes.
Yes, if you go a little down. Okay, right here, line 7. It checks whether the return data size is strictly greater than 31. So why not exactly equal to 32?
Because there are some very niche curve tokens, I think. There's some tokens from Curve V1, the exchange,
remember.
where they return 4,096 bytes. And so if we just use strictly equal to 32, those tokens wouldn't be tradable on Uniswap V4. It's very niche.
One other question about this one. So the free memory pointer.
Yes.
So ABDK was complaining that you guys use a dirty trick. Dirty hack to.
We have fixed the dirty hack.
I think we fixed. Yeah.
But Solana uses that in another library.
Solana does use that. It does not break anything, but it is not guaranteed that the compiler wouldn't break that in future, which is why we have fixed it just to be like extra safe, but it's fine.
So with the current version of Solidity and earlier, it is correct?
It's completely fine.
Okay, but for future, if somebody changes your version, then that may result in a problem.
Yes, and we have fixed it.
Thank you.
That was a dirty hack, though.
That was.
Any other questions? No, nice.
There's one more custom type.
Oh yeah.
Slot 0. This might be my favorite one.
This was written by a community member.
Yes,
Was
it
merged pretty late.
was. So slot 0 is, so maybe we should talk about slot 0. So slot 0 is the first slot in the pool state. And we wrote a custom type for this because when used in memory, that struct was actually not packed. But we can use this custom type, which is really just a bytes 32, to access a bunch of different variables that we want to hold in this first slot. And so what we packed is the current price, the current tick, protocol fee, and the current LP fee on the pool. And you can access them very similar to what we showed with the balance delta. So just slot 0 dot square root price x96, tick, protocol fee, LP fee.
Yeah. Looks
I like
messy.
this trick.
Yeah. It got merged pretty late before audits, but great community member contribution. So you can see it. Oh, wait.
Pool. Mm-hmm.
For example, here, slot 0 dot square root price x96. That's just calling that library and extracting that small part of the bytes 32 where it's stored, packed, even in memory. Nice. I think that's all. There's one more custom type, but we'll come back to it later.
What is that one?
The before swap delta.
Oh, yeah. Okay, well, actually, let's talk about hooks then.
Yep.
Okay, hooks. Let's see. Oh. Okay, so we talked about hooks being essentially these predefined call sites, or essentially in the middle of before, after our swap logic executes, we're calling out to a hook if it has these permissions. So in hooks.sol, we define all of these permissions here. So I think we have 12, no.
14 positions with 10 hooks.
Yes. So we have before and after initialize, before and after add liquidity, before and after remove liquidity, before and after swap, donate, and then we'll get into these later. These are special permissions. I think maybe it's interesting to talk about, so we used to have a before and after modify liquidity hook, but we actually changed it to be before and after add specifically and before and after remove specifically. Can anybody think of why? No?
Throwing it out to the room.
Yeah, I just want to see. So if you think about each of these flags, we're essentially defining a really special permission that hooks have. And this can be really scary. And so one of the main reasons for defining each of these separately, we don't just have one flag that says, yeah, a hook can call any of these things if it wants to, because then you wouldn't really know the granularity of permissions that the hook has. If we define, the more permissions we define, the more granularity we have into knowing the control and the permissions that the hook has. So by separating out before add, after add, before remove, after remove, we can separate this sort of scary thing that a hook can do, which is on any kind of remove liquidity. If a hook just reverts, that liquidity is now locked in the pool. You're not going to be able to pull any liquidity out. Whereas on before add or after add, if it reverts, you're just not going to be able to put anything in. So it's a much scarier permission if the hook has before remove or after remove. And so that's one of the main reasons we actually split out those permissions, separating add from remove.
You should talk about the addresses.
Yes. So the other nice thing about hooks is that each of these flags are essentially, we require hooks to mine certain addresses, and that's how we determine the permissions of the hooks. This is really nice because, well, it means that a hook can't change its permissions ever. If you wanted to launch a hook with a new permission, you'd have to deploy a new contract with a new address. And it's also just a nice gas optimization.
Yeah, you don't have to call out to the hook to ask it what its permissions are. Essentially, if you have the address of the hook, which you do when you're looking at a pool, these, if the fourth bit, I guess that's the fifth bit from the left, is a 1, it can add enough to donate a hook. And if it is a 0, it can't. And so you can see that all just from the hook address. And they are the least significant 14 bits of the hook address.
Cool. Questions? Okay, I think we should do custom accounting.
Okay. Where to start? I guess we'll go to the swap function. Oh, no, I can't search there for a function. So to give ultimate powers to a hook, this idea Sarah talked about earlier of why V4, what's it adding on top of V3? Well, we want people to be able to innovate on what an AMM is without having to write an entire AMM themselves. In the past, people had to fork code and make little changes to add cool features, and we saw some amazing innovation of what features could be included in AMM. But if you're forking code that you didn't write, we've seen various examples of where people make a change and they don't realize the implication of the change that they're making, and they accidentally introduce a vulnerability. And through the use of hooks, you can innovate on what an AMM can do without having to rewrite an entire AMM yourself. You can just insert these pieces of code in a safe way and play around with cool functionality. And one of the many things that a hook might want to do includes taking a fee. Let's say the hook is providing some cool service. There's extra interest coming in some way. They might want to be able to take a fee, and they might want to be able to, they might not actually want to follow the custom, the concentrated liquidity AMM curve, like the predefined V3 trading logic, they might actually want to implement stablecoin optimized trading curves or something else. And all these things need to give hooks more power. It's not just implement a little bit of logic. They need to be able to essentially alter the user's action. To take a fee or to change the trading curve, they need to be able to implement extra logic to change what the user was actually intending to do, which is scary. And so that's why we have these extra flags. A normal hook that doesn't do these sorts of things would just have the normal, let's say, before and after swap flag, and they can't alter the user's actual, I mean, they have a bunch of powers and they can still do crazy things, but they can't directly edit the amounts of the user's swap. And we have 2 additional permissions for swapping: before and after swap returns delta, which means the hook is allowed to return a delta itself and alter, like that delta is applied to the user's swap and changes the amounts in the swap. So did that make any sense? I hope so. Okay. So the key parameter to think about in this is these are the swap parameters that people pass in. There's other parameters, but these are the swap specific parameters passed in for a swap. And this amount specified is really crucial in custom accounting. So amount specified is, if you could think about, there's 2 main types of trade. There's exact input trades, where a user says, I want to trade 1 ETH for USDC, and that USDC is a variable amount. They don't know how much USDC exactly is going to come out of the trade, but they want 1 ETH to go in. And so the amount specified is that 1 ETH. Or they could say, I want to trade ETH, and I want to receive 2,000 USDC. And in that trade, the specified is the output. It's an exact output trade because they're saying, I want 2,000 USDC. I don't know exactly how much ETH that's going to cost me, but I want 2,000 USDC. So this amount specified can be positive or negative. If it's negative, it's an exact input trade. It's that 1 ETH in. Or if it's positive, it's an exact output trade. But that specified amount is what the user always wants. And that, through custom accounting, can never change. A user says, I want to trade 1 ETH. They will always trade 1 ETH input, barring a couple of side cases. but on any pool with a lot of liquidity, they're always going to trade that 1 ETH input, and hooks can then alter the trade behind the scenes, but the user's balance is always going to go down by that 1 ETH. So we have one more custom type called the before swap delta, which is a lot like the balance delta, but instead of having currency 0, currency 1 for a pool, it's specified token, unspecified token. And when you have a trade, exact input ETH in for USDC, you don't know in that moment which one's specified and unspecified without thinking about it, and so it just returns, you don't know which one's currency 0 and which one's currency 1 without thinking about it a bit more. So this one just packs specified and unspecified for a trade. And it's a delta that the hook can return before swap. Okay, here. So this is our internal accounting for the before swap logic. And so if the hook has a before swap flag, it calls out to the hook on this line with the before swap call. Dynamic fees, we'll get into that later. If it has a dynamic fee, it maybe lets it update the pool fee. And then if it has this permission, before swap returns delta flag. So if this pool has this extra permission to alter the user's swap, it amount to swap is this amount specified I told you about earlier, that the user has said, this is what I want to trade. The hook can return a delta to update that behind the scenes. So the user still puts 1 ETH into the pool. Let's say the hook then says, I want 10% of that as a fee. And so the actual amount that gets swapped on concentrated liquidity has gone down to 0.9 ETH. And so the hook returns this delta of 0.1 ETH saying, I want 0.1 ETH. And only 0.9 ETH then gets swapped on concentrated liquidity. The user is seeing 1 ETH leave their wallet. so they're still getting that swap that they wanted. They're going to receive less output tokens, obviously, because the only 0.9 ETH was actually swapped on concentrated liquidity. But as long as it then reaches, it then meets whatever their slippage requirements are, that sort of thing, then the swap will still go through. And similarly, the hook can alter the unspecified currency. Maybe they want to take a fee on the unspecified instead. Maybe they want to take a fee on specified. Maybe they want to have some reward system. If you trade on our pool in the next week, we'll give you an extra 100 USDC towards your trade. So they can add things into the swap as well. So in that world, let's say the hook says, I want to reward every swapper with 0.1 ETH. That would be a nice hook. But let's say that happens and the user says, I want to trade 1 ETH. Behind the scenes, the hook says, I'm going to add another 0.1 ETH onto that. 1.1 ETH then gets swapped on concentrated liquidity, but the user's still only seeing 1 ETH of their money going into the swap, and then the user will end up with more money out of the swap. So this hook delta, the before swap delta, allows the hooks to alter these trades in this way, but the user's action should always be what they specified, except the one edge case of if a pool is running out of liquidity and there's just not enough liquidity available to complete that whole trade, that's the one time a user doesn't get the action that they wanted. And that's true on V3 as well. If it just runs out of liquidity, then you just get like a sub trade. But otherwise, the user's action should never be altered. And if you find a way it can be, we would like to hear about it.
And I think that example was really cool. That was like a hook that can take a fee. This is a very, very powerful permission. If you can imagine taking this a little bit further, what this means is that a hook can actually implement its own AMM and completely bypass the concentrated liquidity AMM. So if it takes the full amount of the user's the user's amount specified, but then gives a different amount specified back to the user, that would be a form of like what we're calling custom accounting or custom curve. So it's really, really powerful.
Yeah. And the user still sees their trade happening, and what they don't know is that that trade didn't go through concentrated liquidity. It went on some other trading curve that could end up being more efficient. If you've got some stable coin specific trading curve, then they could end up with better prices. They receive all the money that they wanted to, and no money actually went through concentrated liquidity in the singleton contract. We similarly have custom accounting on modify liquidity, but it's because we want to maintain this property of the user's action doesn't get altered. So here's modify liquidity, and here's the parameters that get passed in. And a user passes in the liquidity delta, which is the number of liquidity units that they have in a pool. And that's on concentrated liquidity, and this is all very concentrated liquidity specific. And so the pool, all the pool can do is add, like essentially charge fees or reward the user, but they can't stop the user from adding liquidity or removing liquidity from the pool using this balance delta. So if the user says, I want to add 100 units of liquidity, which is converted into 0 and 1 behind the scenes, they will always do that. And the hook can't take all of that money and not add any to concentrated liquidity. So for both of these setups, it's the hook has powers and they can do cool things, but they can never, from the user's point of view, alter their action of what they were setting out to try and do. And that's what these four, these 4 extra flags are these returning delta flags, because these are fairly scary permissions that a hook can have. And yeah, best to separate it out as an additional permission. Yeah.
Can those be applicable, or is it just the permissions be immutable?
The permissions are immutable, yeah. If you,
And the whole contract can be upgradable.
a hook contract could be upgradable. I would say that would be a red flag for me trading on a pool, knowing that the logic of what the hook does could change at any time, because particularly if it had these flags, but it would be scary anyway. If a hook has a remove liquidity flag, let's say, and it currently doesn't do anything evil, but it's upgradable, then I could add liquidity, and then the hook gets upgraded and reverts on remove, and then I've lost my money forever. And so I think I personally would find upgradable hooks scary. But I do think there's probably going to be some valid use
yeah.
cases for them. It depends which permissions the hook has.
Yeah.
If it didn't have these delta flags and it doesn't have the remove liquidity ones, then there's minimal power that the hook could have. And so then if it's upgradable, it's not too scary because it doesn't have the scariest permissions available to it. If it has these scary permissions, then upgradable is then scary.
Hence, going back to kind of the importance between separating out a lot of these permissions. Like swappers can be fairly certain that, you know, any hook with just before initialize, after initialize flags is going to be pretty safe. So, yeah. Questions?
Are we done on
Cool.
core?
I feel like, how much time do we have?
We got time.
Maybe we just quickly touch on 6909s.
Oh, yeah.
Yeah.
This one? No. I feel like it's
Uh,
easier just to see it in here.
Yeah, maybe just do the mint burn.
Oh my God. There we go.
Cool.
There they are.
So we talked about how you can apply deltas, positive and negative, taking tokens, sending tokens into the pool. One cool feature about V4 is, I kind of like to think about this as we have certain deltas. They're written to transient storage space. You can clear and settle these deltas by essentially transferring them to ERC20 storage. So that's taking the token out of the pool or transferring the token into the pool. But we also have these two functions, mint and burn. Mint and burn essentially account these deltas, but instead of giving you the underlying ERC20 token, it'll mint you an ERC6909 token. Or vice versa, you can essentially burn an ERC6909 token and essentially take the underlying ERC20 if you want. And so really this is kind of just an optimization. Probably like pro traders or pro LPs might use this if they want to keep their ERC20 tokens in the contract and just essentially hold these wrappers around whatever balance they have in the contract. And you can really think of 6909s as like optimized 1155s. So it's just an ERC standard that's a bit more minimal and optimized.
There we go, this one.
Yeah.
This balance of mapping. So if you decide to mint yourself a representation of the token and it stays in the contract for gas reasons so you don't transfer it out, I expect our regular users will never be doing this, but if you're an arbitrager who's trading every single block, then the gas cost of transferring your tokens in and out of all these contracts really adds up. This allows you to leave your tokens in the contract, and this mapping will be updated. You are the owner. The ID is the address of the currency that you've minted yourself, and then this is your balance. So if you mint yourself USDC, it'll be your balance here, and this will be the USDC address, so that you can then burn them as the inputs of a trade later without transferring in and out.
And so I think it's worth noting that in Periphery, we don't directly actually integrate with anything 6909. But when we go through some of the code, we can show you how one might kind of write wrapper contracts around some Periphery code if they wanted to use 6909 at all.
So your Periphery does not require any sort of operator permission to interact with these assets?
Oh,
Not on 6909.
on our Periphery code, so our router and our position manager, which we'll walk you through shortly, you can't use 6909s currently.
There's a way you could.
Yeah, there is an edge case of how you could, but because we view it as something that very optimized users are going to be using, it's going to be often people who've written their own smart contracts who are writing really gas optimized contracts for their exact use case. And largely those people probably wouldn't be using our peripheral contracts anyway. They're trying to create the most gas optimized possible thing for their use case, in which case they'll be integrating directly was our thought. But there is like a back way in that you could. you
Yeah,
could use
if we
them.
have time, Sauce can walk you through like how somebody would integrate with our position manager to leverage 6909s, but we don't directly support it.
Nice.
I think that's a good segue into periphery, unless we have any last core questions.
If there's time.
Yeah.
otherwise-
Yeah, go ahead.
So in Full.Sol, there is a place where you argue that greater than or equal is cheaper than greater.
Yes. Where is
Yes.
that?
So I just am curious for my knowledge. I don't
Is it this one? Yeah.
Why? Because in inline assembly we have GT and LT, but we don't have equivalent of greater than. So how is that? Why is that?
It's because it's the difference between in assembly GT or GT and not LT. So it's two, but
That would be the opposite. Because you are saying greater than or equal would be not LT.
yeah, I'd have to dig into it more. I wouldn't be surprised if changing it now with this number of optimizer runs, it's no longer cheaper. So for all of these things, we have have gas snapshot files for everything we ever do, basically. So any change we ever make, we have these. This is the amount of gas for a simple add liquidity, and we have probably 50 of these files. And so every time we make a change like that, we're checking against gas. I believe that one came in from a community member, and it did indeed
We
make
did
it
test
cheaper.
it. Yeah.
I know.
Yeah.
I've seen it other places, but I just didn't know the underlying.
Yeah, I do see what you're saying. I'm gonna have to think about it.
I actually read it strange, and it's about how the jump line code is generated. How the jump line code is generated. It's a jump up.
Oh.
I'm gonna come to that.
I love this.
Perfect.
Yes.
We actually spent some time getting Foundry to change how they do gas.
Yeah.
To make it.
We actually, and we had an actual custom library that Mark wrote, but this is really what we use for our gas snapshots. So we call snap last call. We also run all of the tests with Isolate, which was a new feature that Foundry released, which made our gas estimates a lot more accurate because it would represent like the entire transaction being sent.
Yeah. I think for a while, Foundry's been known as having bad gas. So they added.
We think this improved it quite a bit.
We now think it's pretty good. But
there's still sometimes a few, I think, discrepancies, but I think it's pretty good.
So they added two main things that help. So first of all, when we run tests, as Sarah said, we instead of running forge tests, we run forge test -- isolate, which essentially runs every single line of the test comes out, is sent as a new transaction. Previously, because the tests are written in Solidity, the test would be run as one transaction, which means if you're transferring tokens and then you're performing a swap, those get bulked into the same transaction. And so the gas of the swap isn't quite right because it's maybe using storage slots that have already been warmed and stuff like that. So Isolate runs every line as a new transaction. And then they introduced something called VM.lastCallGas, which is a Foundry cheat code, which if you have this line directly after a swap line, let's say, it will tell you the exact gas that was used in this isolated transaction, which is what we use.
Which is just snap last call.
Snap last call is just a library that wraps around last call gas, and it looks it up and it writes it to a file for us. This gas snapshot is a cool library that actually someone on the Uniswap team wrote. Our manager, Mark, wrote this library. Oh, this is pretty zoomed out. That just creates this wrapper. So if you import this into your repo, then you can use snap start, snap end to like see all the gas that's used between two things. And our favorite is snap last call, which is this one that tells you the exact gas that was used in an isolated transaction before. So Isolate and this library together, we think now give good gas estimates in Forge.
Right. Yeah, so you can see we're importing it here. It's this gas snapshot library, and then all of our test contracts inherit this gas snapshot, and so that's how we're doing the snap last call. Pretty cool.
Nice.
Let's do periphery.
Periphery. Does anyone need like a couple of minutes to use the bathroom or water or anything? Or otherwise, source point will
Take it away.
roll straight onto periphery. Do you want to use your laptop? Yeah? Okay. Yeah, do we need to, who did it on my laptop? We'll see. Did you plug it in earlier? They had to do some magic trick on my laptop to make it work. But I don't know who it was. It was him.
You can use yours if it's.
He's coming. Thank you. Sorry, MacBooks, everyone.
I know. All good. All good. Just make sure. Cool. Is that good? Okay. Hey guys, I go by Sauce. I'm with the foundation. I guess if you guys want to see the GitHub, this is me. If you guys like Tokyo Revengers, let's go. So I guess I'll be going through periphery today, specifically like position manager. And so in V3, like V4's position manager is really a lot different than V3's. In V4, it's kind of closer to like universal router, kind of like a command style contract. And this is, we made this decision because we realized that people want to possibly like leverage flash accounting and like essentially batch a bunch of operations together. So you can do things like collect fees on one position and increase liquidity on another position without having to like shuffle, like actually like pull your tokens out. And so we have like these actions that we defined, the classic ones like minting a position, burning, increasing, decreasing. And then we also have like these delta resolving functions. So like on mint, you might, settle pair, so you're paying 2 tokens. On decreasing liquidity, you might, take both pairs. And then there's also some weird edge cases where like you would maybe pay, like if you were on ETH USDC and you want to take a portion of your ETH and put it into like ETH BTC, creating a new ETH BTC position, you might not pay ETH, but you might pay net new BTC. And so these are the actions and the commands. And the entry point into position manager is quite similar to like universal router, where you kind of encode these operations. This is kind of like what it would look like, where, for minting, you are, encoding the mint position, and then you expect to pay the pair, and then you encode the parameters such as like the pool, how much liquidity, you specify slippage, and then you would then specify like which currencies are paid. But in terms of like what the actual flow looks like, we have this new base contract, base action routers, where like Sarah and Alice previewed, we unlock the pool manager, we re-enter in the unlock callback, and then we kind of loop through the sequence of operations that we encoded. At the very end, position manager would then settle the deltas or resolve the deltas, making non-zero delta count 0, giving you a successful transaction. And so this is kind of like the handler. And if we go into position manager, we see this crazy sequence of decoding the commands. And so up here we have a bunch of like the major liquidity operations, such as like increasing, decreasing, minting. And then down here we have like the delta resolving functions. So like this is kind of where like token and value transfer happens. Inside Mint, a lot of the liquidity operations follow the same pattern where you have some parameters, and what happens under the hood is it makes a call to modify liquidity, which is, you know, just a pool manager call, where you specify like, here's the pool key that I'm operating on, the tick range, liquidity change. And then we have this new parameter called salt. It's a little hard to describe. So in V3, if two people were on the same range, in the core contract V3 pool, that liquidity in that state would be shared. It was a gas optimization thing. And then on position manager, you would kind of map token ID to underlying liquidity. In V4, it's slightly different where there is no really shared range. We could do shared range, but we actually found it to be more gas efficient. And so this salt will like uniquely identify your position in pool manager. And so that kind of makes position manager in V4 semi-stateless, in the sense that like, I wish I had the V3 code up, but in V3, in the position manager in V3, you're tracking liquidity, you're tracking fee growth. I think those are like the two things, and then like tracking the owner. Whereas in V4, we just have token ID, which just kind of maps to this position info containing, you know, what pool it's on, what's its tick range, if it has a subscriber. So we actually don't track anything about liquidity or fee growth. If you wanted to do those lookups, you would actually want to reference the pool manager. We have a helper function. And so for a given token ID, you can see that we look up its, you know, underlying information and make a call to pool manager to actually get the underlying data. I'll pause here. Are there any questions from the?
I noticed you got rid of amount min 0 and amount min 1. It was in position manager of V3. It's not here anymore.
We did add, we re-added slippage. Is that what you're asking? Or, oh, you're asking about the Mint interface.
Yeah, there are maximum amounts, but there are no minimum amounts.
I think in V3, we had 2 function signatures for Mint. One of them was where you would specify just token amounts, and it would automatically calculate your liquidity, and then kind of determine token amounts based on that, like amount 0 and amount 1. Whereas in V4, yeah, you kind of have to just calculate the liquidity, and then.
Oh, and those values are only for slippage protection.
Yeah, these values are only for slippage. There was like an ergonomic function in V3, I think is what you're referring to. I guess that's a good segue into slippage. So in all these major functions, so whenever you're paying tokens, so on increased liquidity and minting a position, you kind of specify like a maximum amount, like how much I am willing to pay. And then on the decreasing positions or collecting fees, you kind of specify an amount minimum where I am pulling liquidity out, therefore I expect a minimum. And so a lot of these operations have these parameters, amount 0 and amount 1. And where slippage is enforced is after we modify liquidity, we have this helper function given the balance changes that we expect to see. Are they within our like tolerance limits? Let's see, what else? One thing that's also unique to V4 that isn't in V3 is in V3, whenever you fee accounting is done separately and independently. So if you wanted to collect fees, it's a separate call. Whereas in V4, because of flash accounting and gas optimizations, whenever we increase liquidity, your fees will actually be automatically credited to your liquidity change or your liquidity delta. So normally, like if you want to increase liquidity, you're expecting to pay tokens. And in V4, what happens is these fees will be credited towards that payment. And so liquidity delta, this balance delta, is the final delta that you're expected to pay, which includes the fees credited to the position. We do return it separately just for accounting reasons. And so we can see here that like the slippage checks are done on the principal liquidity, which is like the underlying amount of tokens that you should have paid had there were no fees. And so that's, oh, I guess I can also go into Clear here. So this is a good use case of Clear that Sarah walked through in Core. And so there are times whenever you are possibly doing some crazy liquidity operation and there's like a slight amount of tokens that you need to collect, like, dust amounts. And so we have this function Clear that you can kind of encode saying like, at the end of the operation, if there is a positive delta that I need to collect, I can either forfeit it or I'll take it, specifying like a maximum amount I'm willing to forfeit. So you can see here that if the amount is less than the maximum, then we'll just go ahead and forfeit the tokens. Otherwise, we can choose to collect them. Speaking of like forfeiting and stuff, we have this sweep function, which is strictly for, I think, native Ether. So there's cases whenever you're increasing liquidity, you don't know the actual exact amount, or like the price moves just slightly, therefore your ratios kind of change. And so whenever if you were to like increase liquidity, you would specify like an amount. There's this like sweep function where you can then collect any sort of excess payment that you make. The last thing I wanted to possibly touch on too is this notion of subscribers. Another sort of difference between V3 and V4 is we have this thing called like subscribers and notifications. So in V3, if you wanted to do staking, right, you would spin up this new contract where it would do all this like reward handling, and in order to like claim these liquidity mining rewards, you would have to deposit your full NFT, doing like a full transfer of this NFT, which would give that staking contract more or less full ownership over your underlying capital. And so in V4, we have this thing called like subscribers, where you can kind of call this subscribe function. Me as the owner, or if somebody is approved to operate on my token, I can say like, for this token ID, I want to subscribe to these rewards. And it's this address that gets sort of pinged and poked every time there's a major operation, allowing you to sort of reap the benefits of staking without actually having to forfeit your underlying, or like put your underlying capital at risk. And so these subscriber functions, you can kind of think of them like hooks, but for liquidity positions. And so these contracts get notified on subscription on the first time somebody subscribes. So if I subscribe to Alice's contract, she gets notified. She gets notified if I change my position. So if I increase the liquidity or decrease it, she'll receive a call. If I transfer it to somebody, if I transfer it to Sarah, Alice will be aware. And then lastly, we also have unsubscribe. And one of the things we did here was enforce like a gas limit. This is so that like subscriber contracts can't grief their users. There's should be a way where, if this subscriber contract is like somewhat malicious, or it's not like actually paying out rewards, and I want to, subscribe to somebody else's reward logic, I can like forcibly remove myself, where like if the unsubscribe happens to revert, it'll, be try-catched and will succeed. I think that might be everything. Sarah, is there anything else that I should go into?
Does everyone understand subscribers? That's one area where we're like,
Yeah.
more issues about helping the audits and subscribers than other areas of the code. So if anyone has any queries about how subscribers work, I feel like it's a good thing to try and understand. Have you talked about the market
Oh, no, I haven't. Yeah. Okay, so I guess I did mention there is one entry point, but it's actually two. So we have this other one with a cursed name, modify liquidities without unlock. It's exactly the same as this first one. It's just instead of unlocking the pool manager and sort of looping through these actions, it's for whenever the pool manager is already unlocked. And you can think of it like if Universal Router already has unlocked the pool manager and it wants to do like a swap and add, if Universal Router were to hit this entry point, modify liquidities, it would revert because the pool manager is already unlocked. So this is for logic where you want to interact with position manager where the pool manager is already unlocked. So like another interesting use case might be like if I have a token and I approve a hook, and in after swap, maybe every 100 blocks or something like that, this hook in after swap would be able to collect my fees and then like auto compound and increase liquidity, or like do something with my fees, or just do something with my position, or like in before swap, because you are unlocking the pool manager in swap router, it's hitting pool manager then calls to the hook. Pool manager is already unlocked, so therefore the hook could access my position with this function and be able to essentially do all the amazing and cool, complicated interactions that are possible, where a hook could possibly create a new position for me, or reconcentrate my range, or do like rebalancing. That's one area that we like wanted to test but didn't have a lot of time doing, and so could be an interesting area to look as well. Which kind of goes into 6909s a little bit. Like we defined the actions here, but if you were to like search this, we actually don't like decode these parameters. But in theory, if you were like a hook or like an integrating contract, you could unlock the pool manager, encode operations for modify liquidities, do a bunch of liquidity operations, and then you, the contract writer, could then like facilitate the 6909 transfers. But right now, yeah, position manager only operates on ERC20s and native ETH. And because we do native ETH and we are supporting multi-call, this is kind of just like a classic multi-call function. But the idea is like you could, I think we have a test where like essentially the position manager would look like something like this, where you can like multi-call like and initialize, like you can create a pool and like mint liquidity. And then this value, like if you were to mint liquidity on like a ETH and token pair with native ETH, you would want to provide native tokens. And so there's like weird cases where we, essentially because it's multi-call, you have to, every function that you're calling through multi-call has to be payable. So there are some weird incidents where like these functions are labeled payable. Like if you wanted to give permission to somebody and they wanted to, send ETH to your position.
Can you explain that further? I was wondering, why is this payable?
So I wonder if I can find this test. Shoot. that's not it. I don't know if this is it, but essentially, like, yeah, it's not it. Whenever you're multi-calling, any function that you sort of encode and you're passing message.value, it has to also be payable, otherwise it will revert, essentially.
And would you guys at some point consider making multi-call MIT? Request.
Which one? Multi-call?
Multi-call.
Is this not MIT? GPL. That's not my decision, but I am generally in favor of like multi-call. Like the other day, I like approved, I think, no delegate call. They were asking for MIT, and
Some of the licensing is not, like, final.
yeah, we still have to do a pass.
So if there are specific things that you think would be nice to have better licensing on, definitely flag it to us.
If you put like an issue on the repo or
Yeah.
something, we have to sync all of these, obviously. We don't get to make any of those decisions, but we take all of them to the right people to make sure those decisions get made. So if there's something you'd like to see changed, just flag it on the repo and we can discuss it internally for you.
Thank you so much.
I would say generally we're pretty in favor of permissive licensing, specifically with things like this, where other contracts might want to use like a multi-call or like an ESCS or whatever it might be. So yeah, just flag it.
Will do. Thank you.
There.
There's a test multi-call on payable revert, which I know, or maybe just looking at multi-call text file.
Yeah. Whoops. Oh. Yeah, so if you are using multi-call with message.value and one of your functions is not payable, like I believe this function is non-payable, it'll revert despite the first one being payable. Yeah, so this is not payable, but the first one was payable, and therefore, like, in order to multi-call with message.value, every function in the sequence has to be payable. And so we have like these weird edge cases and weird functions that are labeled payable but don't leverage message.sender at all, or message.value at all. Well, cool. I think that's all from me. Were there any other questions, or anybody else want me to deep dive on any possible differences between V3 and V4? We're the router. Sure. So this is the V4 router that universal router will use. I'm not super familiar with this code, but I believe like these. Alice, what's that? He just wanted to see the swap logic for V4. You'll go through that. Okay. Okay.
I'll go through the router in a second.
Well, cool. I think there's another question. Oh, two.
Any difference between NFC positions?
Differences in the NFT positions? No, I don't think so. Yeah, I did go into that. So like in V3 and V4, they're both 721 receipt tokens. They both support like signature-based permissions. I guess V4 is a little bit different where we have permit for all, which is the equivalent of set approval for all in 721. Oh, yeah, that is different. That is different. So in V3, if you wanted to do like a permit where I essentially sign and say like, Alice has approval to operate on my token, I actually don't have to call approve or like broadcast that transaction. Alice can take my signature and give herself permission to operate on the token. And with these signature-based systems, there's usually like a nonce to prevent like signature replays. In V3, it's just a number that just increments. In V4, we use the unordered nonce, which is kind of borrowed from permit 2, where you can kind of sign 2 nonces that are unordered, and it's also, I think, more gas optimized, where essentially the nonce is stored at the owner level and not at the token level. So in V3, the nonce was at the token level. So if you had 2 positions and you sign a signature for one, it's going to be a cold storage, and then for the other position, it's also cold storage. Whereas in V4, it's an unordered nonce that's at the owner level. So you don't have to do a cold storage like every time you have a new position. But at the highest level, yeah, it's like approximately the same. It's still a 721 token ID to map to the underlying position. I guess the V4 difference is there's no state management, really. Mhm. Invariant test suites. I don't think so. Okay. The auditors have wrote the invariants.
I think that should be the invariant test. We've got formal verification as well from Certora. We'll have a panel later with the audit firms as well, but they can talk about it. We did a lot of fuzzing, but we didn't do invariant testing.
Cool. If there's no questions.
Well, hello. We were talking to them about your gas snapshotting library earlier. Oh. Right. I am going to talk about our router. So someone asked a question about swapping, I think. I'll be getting into the swapping logic. So similarly to what Source just walked through, the V4 router also shares this base actions router that Source went through, where this idea of encoding commands and encoding parameters to go with those commands, that concept was, we essentially thought Position Manager and V4 Router both want to do a similar set of things. Yes, one of them's swapping and one of them's adding liquidity, but they both need to, in an unlock callback, execute some number of commands, give ultimately a bunch of flexibility to whoever's calling the contract. So that's how we designed that. And so we then also inherit it here in the V4 Router. This contract is actually abstract, which means this isn't the actual contract that would get deployed. This holds most of our V4 swapping logic, all of it, in fact. And then I'll show you the contract where we actually inherit it in a second. So similarly to the position manager, we have this handle action function, which gets past each action that the user wants to perform inside the unlock callback and the parameters to provide to that action. So we have up here the 4 different swapping commands: swapping exact in, swap exact in single, which is a single hop exact in trade. So it's just optimized for this one hop swap style trade, and then swap exact out and swap exact out single, which is again the one hop trade. Those are the 4 different swapping commands. And then again, down here, we have a bunch of commands for removing your money and paying off your debts in different ways. So Settle, take, pair is just this optimized. You know that when you're swapping, you have one function that you need to settle, and one function that one currency you need to settle, and one currency you need to take. And so this is just an optimized one for let's just settle and take the open debt and the open credit on the contract. And then there's more generalized ones if you want to do something a bit fancier with certain slippage checks and stuff like that in the settle all and take all and various. These are all just various commands around settling and taking with different optionality. So then we get down to the actual swapping logic. All of these functions end up calling this internal, well, private swap function that takes the different commands, the different inputs and encodes them correctly and interacts with the pool manager. It's a very small little function, and it calls swap. And this line in particular, you know how we talked about amount specified earlier? Well, you're passing in your amount specified, be that exact input or exact output, and this reciprocal amount that the function returns is the other, it's the unspecified. Arguably, this variable should be called unspecified amount. It's the amount of the trade that you didn't specify. And then there's these helper functions that, so this is exact output swapping, and it just loops through each element in the swap path and performs a swap on that, for that element in the path. And we have a struct specifically for swapping, which is called a path key, and it just holds, obviously for each hop in the path, you need to know everything about the pool to be able to find it. So it's not just, I want to trade USDC for ETH, you need to know which exact pool you want to trade it on. So you need to know the tick spacing and the fee and the hooks and any hook data that you might, each of the hooks, I don't think we mentioned this earlier, but each of the hooks has an available bytes parameter. You can pass in any data that the hook might want to receive, so you can also pass that in here. So this path key only specifies one currency, because if you specify, it's just an optimization. If you specify your input token, then you already know what one of the two currencies is. So then you just need the intermediate currency at each stage in the swap. You could have two currencies in this struct, but then you'd need to check, is the output from one hop the same as the input to the next hop? And so we'd have to pass in extra data and do extra checks. So this is just one currency at a time of like, what's the next currency in the swap? And you can pass in an array of these path keys, and it just iterates through them like this. Yes?
I want to ask about the hook data.
Yes.
So that's kind of a container that I can pass data to from the router to the hook, basically, right?
Yes.
Now, is there any data that has to pass there, or just whatever I want? And is there any requirement or any kind of structure or anything like that?
No, it can be, I would expect that for a fair amount of hooks, it'll be empty. It'll be, also for there's no hook, you pass in just an empty string. So I would say a lot of swaps will be passing in empty strings. But if I don't know, maybe the hook wants to prove that you have some sort of permission and you pass in a signature to say, I have X permission. You could pass in a signature there, but there's no fixed structure or amount that you have to pass in.
Can I overload this function? Like, meaning for sometimes I pass this signature and sometimes I don't, or give a different type of signature? That won't cause any problem.
No, that all comes down to how the hook defines what it does with the data, but we don't do anything. We just pass the data through. So this is the interface that hooks implement. And so let's say before initialize, they receive this hook data. We never do anything with that data. The pool manager just receives, let's have a look at initialize. It receives the hook data here, and it does absolutely nothing with it other than pass it into the before initialize call. So if there's something in there, the contract never looks at it. It just passes it on. And the same in the router. It can be passed through and it can be passed on to each hook, and you can specify different data for each pool you're interacting with, but we never look at it. Yeah, I feel like, are there any questions about the router? I feel like it's nothing crazily unexpected, hopefully. There's just these various different functions, and they encode. I guess this is one thing we do. We've got various constants called, if we go into action constants, so constants that are called open delta and contract balance. So maybe when you call a contract, you don't know exactly what it is, the amount it is that you're going to want to trade. For example, if you're trading a fee on transfer token input, so your input token is a fee on transfer token. You transfer your token into the pool manager, and you don't know exactly how many are going to arrive in the pool manager because there's some variable fee or something. That arrives in the pool manager, and then you can specify of the swap exact input. You can just say, my input amount for my trade should just be whatever the open delta is. So then this contract goes and looks up what the open delta is in the pool manager, and then says, okay, well, that's the input amount for our trade. And so then when you're encoding your call off chain, you don't actually, or on chain, you don't actually need to know exactly what the input of your swap's going to be. If you've got various steps beforehand, maybe you don't know exactly what it is. You're just saying, when I get to this swap, I want to swap whatever I have available. You could use the open delta constant. And then we have another one that's called contract. Oh, it's not in this one. Maybe it's in here. Yeah, contract balance is the balance of the router. So let's say the router's been transferred a bunch of tokens, and you just want to settle all of those into the pool manager as to put them all in there ready to swap. You can just say contract balance. You don't know if you're going to have 1 ETH to send in or 1.1 ETH to send in. You just say whatever you have, send it in, and then we can start swapping that. So those two constants are just for those sort of unknown swap amount styles. Any other questions about the router? Nice. So then I will quickly show you. Yeah.
So I mean, gave us an answer a couple of days ago, kind of, but what we have here is something that takes basically a set of requests for transaction across the path. It doesn't do the path optimization. I mean, like usually in traditional finance, we say smart order routing and such. The main thing is computing the past.
Mm-hmm.
First of all, could you imagine we'll own the router? I mean, would it be something like the same entity that owns the pool or access to the pool?
You mean who will own this contract on chain, or who chooses which route you're going to trade on?
No. So there will be something maybe online, maybe offline that will optimize on the path. That will probably be some entity that is different than the pool access itself. Right? The pool itself is like contract.
Yeah.
But there is a pool access that can be owned by someone. But what kind of do you imagine? What kind of entity will own this router? Would it be the same entity that does the optimization, or will it be the entity that owns the access to the pool, or would it be a third entity?
So this contract is completely permissionless and will be, maybe I'm misunderstanding your question. It'll be completely permissionless. It'll be deployed and anyone can use it. And we will deploy it probably, but we won't have any powers over who can use it. So anybody can use it for any type of swap that they want to within the rules defined in the contract.
So you think of it as something that is deployed and they're not controlled by any certain entity?
Yeah, and then if a hook doesn't want certain people to trade on that pool, then that's up to the hook to define who can and can't trade on that pool. Or
for instance, the hook doesn't know who's sending the order, right? It's dependent on the router.
Yes.
To provide this information.
Yes.
It means that you have to have a trust between the router and the hook.
Yeah, if the hook might decide. So for example, we have available in the universal router, it will say, oh, it's not in this one. Maybe it's in here. No. There it is. So we have this function message sender, which, yeah, allows a hook to see who originally said that they wanted to execute a swap. Because, yeah, as you're right in saying that the hook only receives the address of the person who called swap on the pool manager, which is normally the router. It's not going to be an end user ever because you need to call unlock. We, for that reason, exposed on our router the message sender function so that a hook or whatever party can look up the address of the person who originally initiated this operation. But obviously, not everybody's router is going to do that. And not every swap that's coming in through a pool is going to be initiated through our smart contract. So it might be that if a hook really needs to know this, the hook might have to say, you can only trade on this pool using this router. And I therefore know that I can then trust this message sender function. But it's not.
That's exactly why I'm asking about this ownership, right? Because then you have to have some kind of connection between them.
Yeah.
Okay. This function, where do I find it?
So we were previously in v4 periphery, which is where the position manager and the v4 router are defined. And then the final repo that's in scope for the competition, but also that we're going to be deploying is, as I said earlier, the v4 router is abstract. This is the universal router repo. And the universal router allows us to have trades that are going through v2 and v3 and v4. While we're here today to talk about v4, Uniswap v2 and v3 are still out there doing a huge amount of volume, and realistically, the best path for someone might be to trade ETH for USDC on v3 and then USDC for DAI on v4. And so we need a router that can not just route through v4, but route through all of them. So this dispatcher contract allows people to trade on v2, v3, and v4, and perform a bunch of other things. So this contract is where we expose the message sender, which is the person who originally called the universal router. And then within that, we have this v4 swap router that inherits the abstract v4 router that we were just looking at in periphery and integrates it with permit2 so that any payment that's going from the v4 router into the pool uses permit2 for the payment to basically avoid anyone having to do open approvals on our router. And then the actual contract that will be deployed is the universal router, universalrouter.sol, which inherits from the dispatcher. And this contract as a whole will allow you to swap on any of the versions of Uniswap, bar Uniswap v1, and will also allow you to migrate funds from v3 to v4 in a single transaction, which Sarah's going to talk about in a second. So for a little bit of context on the scope of Universal Router, any bug that you find in Universal Router is in scope for the competition, but a lot of it's been on mainnet for a couple of years and is pretty tested. So there's certain areas of the code where it might be more valuable for you to spend your time, which is the newest areas of the code, which is the v4 swap command, which is a new command that we've put in for, oh, it's not there, for v4 swapping, which just calls execute actions, which is one of the functions on the base actions router that we talked about earlier. And then the migrator commands, which Sarah will talk about in a second. And then we translated our lock. We have a reentrancy lock on the universal router, so you can get this sort of trust over who the message sender is. And we updated that lock to use transient storage because it doesn't need to persist after the end of a transaction. So that saved a lot of gas to put that into transient storage. So while the whole of the universal router is in scope, there's these particular new things of new features we're adding. V2 and V3 swapping logic has been in there for years. So we're more confident that it's secure already. Is there any questions about routing? Otherwise, I will last 15 minutes before lunch, and we can talk about migrator quickly. Nice.
Okay, cool. This should be really quick. High level, in the universal router contract, we also support migration of liquidity. So that's any liquidity that exists on V3, kind of similar style. It's an ERC 721 representation of liquidity on V3. We also allow moving that liquidity to a pool on V4. So I think actually the best way to look at this is through a test. So it's a little complicated because Universal Router uses these command style actions, and the router itself also uses command style actions. So we kind of see like almost nested actions. But if you want to do migration, let's just assume that we're already operating on some kind of V3 NFT. So there's already pre-existing liquidity in V3. What happens is you're going to initially call the universal router commands for permit. So this is the V3 position manager permit. So the universal router needs permission to essentially decrease and collect the liquidity from V3. So that's going to be this V3 position manager permit call. Then there's 3 calls. There's decrease, collect, and burn. That's going to do all of the actions on V3 to actually remove the liquidity. We can ignore this because this is specifically for a ETH position. But for V4, we have a command in the universal router called mint position. And this is going to call the V4 position manager, which Sauce walked through. But to actually use the V4 position manager like you saw, the integrator has to also encode the settling of any open deltas. And so that's what you see happening here. We encode a settle command. We actually encode 2 for both currencies. But we also have a command called settle pair, which is just, it basically does the same thing, but it's just one action. So in most cases for like mint and increase, you can just use settle pair. That's pretty much it for migration. The high level like universal router action is this V4 position manager call, but like I said, how it's sort of nested actions within an action. These are all of the nested actions, right? So the mint position, the settle, and the settle, these are all actions that exist on the V4 position manager contract. The action that you're encoding to the universal router contract is going to be the V3 position manager calls, and then this high level V4 position manager call. Cool. Any questions here? All right, that's it for, oh yeah.
In this example, you're using Wrap Ether. Does it create a pool on Wrap Ether?
I'm actually not sure in this test.
I guess like if you unwind from V3, it's Wrap Ether and USDC, and then if you want to create it, name ETH and USDC on V4.
Yeah, so you would unwrap the ETH and then add the ETH on V4. So you could do that, but we also support ETH, so you don't have to do the unwrap.
Did you go through the pool initializer in multi-pool?
Yeah, he did. Yeah.
Okay.
So like to that question, if the pool doesn't already exist, you can also combine an initialize call in the V4 position manager, which will create the pool, add liquidity. Cool.
I feel like we're done.
Yeah, I think that's it. Sorry for the very lengthy walkthrough. So I think now we're doing a lunch break. Yeah, are we early? Okay.
So we've got 55 minutes for lunch, and then at 1 it's
Attack vectors, right? Or no? Yeah, why don't you just do the whole download.
Sorry? You have already Telegram group? Okay, I'll talk to the lunch, we'll take it in that, and then people share it on that. Otherwise, I can just find a way, I can use the Telegram.
Cool. Just a quick update. So we are going to do lunch now. Lunch is to my right, where everybody had breakfast. There's a ton of food, so please eat as much as you want. Dinner will be lighter, so I encourage you to eat more for your lunch. Secondly, so what we have coming up, we have three very important semi-events. So we have Certora will be doing the formal verification piece, which is a sizable chunk of the competition. We'll also be having Sarah and Alice going over some potential attack vectors. Again, just some additional alpha for you, as well as a mini threat modeling session. And then lastly, we'll close out the presentations with a panel from a few of the folks that have already audited the code. We have Jose, Kurt, sorry, I don't have my, my laptop with me. Samara, can you give me the names real quick? Ben as well. Jochen from Certora, yeah, I think that's how you pronounce it. But all super talented auditors that will be going over the code and telling you over essentially what type of insights that they found from reviewing the code base, as well as answering any questions that you might have. But it'll be really insightful for everybody to attend that as well. But yeah, please feel free to break for lunch right over there and enjoy. let's,
I could just send it to you. Do you want to
do
do that?
you wanna try it real quick right now?
Okay. Okay. So this portion, I wrote these slides last night, so we're gonna kind of go a little ad hoc here. But mostly today, I'm gonna talk about two major issues in the code base. Oh, there we go. Hello. Two major issues in the code base, what they were, how we fixed them, just to give you some context on sort of like the progression of the code. When you look at the code right now on main, a lot has changed in the last week, in the last month, 2 months. So this is going to take you through some of it. We also did the core code base walkthrough, and we didn't talk too much about the sync and settle mechanism, which ended up having quite a few issues. The Open Zeppelin critical issue was in this mechanism. And so we're going to kind of walk through how that code progressed. And then we'll talk a little bit about some periphery changes as well. And I think that's it. As we go, feel free to ask any questions. And of course, I think after this, we're doing a panel with the auditors. And so anything that comes up here, if I can't answer them, they can. Okay, cool. So we did make a lot of mistakes. I'll just talk about some of them. The first one, so this is Open Zeppelin C01. I'm just writing the names down. They match the exact issues as presented in the audit. So if you want to go and reference that issue afterwards, all of these audits are open source in the code base. So feel free to go and read that afterwards. This one was a really interesting bug. So essentially, an ERC20 token that is also a native currency token, which, for example, in this specific issue, we'll talk about Celo, because this was actually could have been exploited with Celo on the Celo chain, could have been used to drain native currency pools. All right, so what does that mean? It's essentially a problem for any token that had a native representation and an ERC20. So you could transfer it either, using like sending the value, setting a value greater than 0, or by using the ERC20 interfaces. It was not an issue for some similarly designed tokens to Celo because the token contract itself had certain checks, safety checks, that, for example, Celo did not have. But let's maybe walk through an example. So this is the old sync code. If you called sync, essentially what was happening is we were snapshotting the balance of the token in the singleton contract. So this was the balance across all pools, right? Since all of the tokens are in one contract. And then we have a mapping from currency to reserves that we set in sync. This is a transient mapping. We actually used to have this mapping not in transient storage. And when we introduced the sync function, we moved all of this to transient storage for gas savings. But essentially, you could sync any number of currencies at any time. So you could have, like 5 or 6 or 7 open synced currencies at any time. The settle mechanism really just looked at if the currency is native, so we use the 0 address to represent the native currency. If so, it would use the message value as the paid amount. Otherwise, it would snapshot the old reserves balance, so this is the reserves balance that was set when sync was called, against the new reserves balance. So you can see we have UN256 reserves now equals sync currency. So that's performing another sync call, which again, like we saw, gets the current reserves balance. And we'll go through an example. But if when we call sync, the reserves balance is 10, then we transfer 10 tokens to the contract and call settle, the new balance would be 20 and the paid amount would be 10. And so you can see how we look at the diffs in balances to account any new deltas to the caller. So why was this an issue? Let's look at, with the Cello token, what could happen. So this is the ERC20 Cello address. So we're gonna call manager.sync. That checkpoints the reserves, let's say at 100 for that currency. We call manager.settle with value greater than 0. So in our settle code, you saw that then the paid amount would be plus 10. So that's going to be accounted to the 0 address because that is the native currency. If we call settle again now on the ERC20 token, you can see that essentially, since we have transferred 10 in from the native token, our delta is plus 10. So we've actually only sent in 10 tokens into the contract, but we can now take 20 tokens out. And if you repeat this a bunch of times, you can just drain the pool. And so that was the issue with essentially these tokens that can be represented as ERC20s or native tokens. Cool. So our fix to this was to enforce an ordering to sync and settle. So the currency you sync has to be the one that you settle, which basically just means that the settle function looks up the currency address that is now saved in sync. So we no longer have a mapping. You can't have like 5, 6, 7 tokens synced all at once. You just sync one token and then you can settle that token later on. Note that syncing an ERC20 and then settling with a value will now revert. And if you want to look more into this, there's some tests actually in the code base that walk through this exact example. So you can try playing around with it, running some tests. Any questions? Okay. So this actually ended up opening a can of worms for us in the sync settle mechanism. One issue flagged from Certora, I believe, was in the old sync code path, if you tried to sync another, so let's say you'd call sync, it sets the sync slot to, say, the Cello token. If you tried to call sync again on another ERC20, it would revert. This is really interesting because it opened up a new DOS vector. So let's say you wrote a contract that maybe batches swaps or something. If in the duration of one of those swaps, a hook were to call sync and leave it open, that would essentially mean that the subsequent caller is forced to settle that token or forced to revert the entire transaction because it can't actually override that synced currency. So the current code that we have now in main handles this by actually overriding the sync slot. So if you call sync again, but the slot is already written to, it'll just override the slot. Okay, that's what I just described. And then settle works the same, where it just operates on the currency set in the synced slot. And this is the final sync and settle system code that's on main. What can we learn from this? We kind of touched on this earlier, but this line of code is really critical, I think, or really anywhere in the code base where we're calling account delta. If there are any assumptions before we call account delta that are incorrect, this could be really a critical bug or a critical issue. And so looking at, and basically any of these external functions or internal functions that end up accruing a delta to a caller, that's going to be really critical code. Cool. Any questions? Just some other core callouts. Another fix to the sync and settle mechanism was that the function sync used to not have the only when unlocked modifier. So we saw this earlier during the code walkthrough. All that means is that you have to call unlock before you can call any of the functions in core. Sync actually had the property that that was not the case. You could call sync outside of the unlocked state. We've now changed that, and we've changed one of the functions in protocol fees to actually only be callable when you are not in the unlocked state. So it's a little confusing, but before you call unlock, there's a function that you can only call. And this was just because it could have messed up the reserves of the contract and causing a revert. This one's really fun, Certora M02. I'm not gonna dive into it because it's also a can of worms. We actually didn't end up fixing this, but just a quick summary of this issue is that a tick may not exactly line up with the ending square root price x96 on a pool. Feel free to read over that issue and ask us any questions about it. It's a doozy.
We added a lot of comments to the code around this issue. So it was going to basically require a complete re-architecture of the swap algorithm to fix it. So we did it in the end.
Yes. Yes.
How could it mess up if you don't require unlock modifier for sync? What could possibly be?
So in the protocol fees contract, there's a function that allows the protocol fee controller to take any fees that it has accrued. That means that the balance of the contract would be less than. So if somebody had called sync, meaning set the reserves of the contract in the code, but then the protocol fee controller somehow gained execution control, called collect protocol fees, though the reserves of the contract would now be changed and it would be different from what sync had set. And so in order to fix that, you have to require that sync is only called when the contract is on lock, but the protocol fees collect function is called outside of the lock mechanism.
Collect actually transfers the fee values outside.
Yes. Yes. Okay. Periphery. Or any questions here before we move on to periphery? Okay. Okay. Open Zeppelin C01, accrued fees can be stolen. So this kind of speaks for itself, but as TLDR of this issue is that we did not require increase to have certain permissions. So basically you could call increase with one way and take all of the fees underlying in that position. And this was a funny one. Diana messaged me on Slack and she was like, why do we require approval on increase? I was like, I don't know, I forget. Let's remove it. So this learning is don't YOLO remove stuff. Okay, last thing I'll talk about is the subscriber mechanism in Periphery, because as we talked a little bit about before, subscribers is a fairly new change we've made, and there's been nothing like it in V3 Periphery. So it's really kind of some critical code. What is subscribers? Essentially, it's an optional feature that allows a user to specify an address, which will become the subscriber of an ERC 721. So that subscriber, once the user has opted into a subscription, will receive any notifications upon any modified liquidity of the code. This is really cool. You could imagine like a staking mechanism designed around this, where instead of sending your 721 token to an external contract that now can really do anything with that position, you can just add an external address as a subscriber, which will receive notifications about if you've changed any, the range or, any kind of increase or decrease on the position, etc. So yeah, this address will receive any updates. The one, I guess, critical feature with subscribers is that we must require that an unsubscription be safe. So this is actually really similar to kind of the scariness of, say, like a hook on before or after remove liquidity. If a hook reverts on before or after remove liquidity, that liquidity is locked. Similarly with like an unsubscribe, if something unsafe were to happen, that liquidity could also be locked. So there was quite a few issues here. I'll just really quickly screenshot some of, this was the old unsubscribe code. So there was some CEI did not adhere to ChecksFX interaction. So you can see like we're deleting the subscriber after that call to unsubscribe. But also, we don't actually check if the contract has any code. So this is really important because what we're doing here with a try catch is just saying, no matter what happens, we want this code to succeed. We want the user to be able to unsubscribe, but calling a contract with no code would cause a revert here. And so this is what the new code looks like, where we now have to check the code length. Also, you can see we move the delete above. So we now check the code length. We also check that the user has sent enough gas in for the call to notify and subscribe, and then we catch it. But the key thing to point out here is that if this line reverts, some of our fundamental assumptions about unsubscribe are no longer true. And so this is a really important piece of code. That is all I have. Any questions? Yes. So it's not an exact replacement of the staker. We actually don't have a canonical staking implementation. I think if we were to write a canonical staker, we would use it as an external subscriber. Yes. Okay, cool.
and then I'll come up.
Okay, good afternoon, everybody. So I'm Muli Sagif from Tel Aviv University and Certora. We are here 3 people. We have half an hour, and we need to convince you to participate in the competition and actually to get some reward from Uniswap. Thanks to the Uniswap team. So how many of you are already participating? Raise hands. Oh, fantastic. Great. Amazing. So actually just Armen and Jochen, they will explain more technical things, but notice that the competition is a bit different than the oil because it's not actually code that we formally verified. So it's good for you. It's good for you. We actually, I think so. I hope I'm right. Okay, so that's great. So please help us. And the introduction that we have is a bit basic. There's a lot of things about it. So what is formal verification? For those who are not participating, it's the art of showing that your program does what it's expected to do or find bugs. And actually, it's a big field of computer science, a lot of very good people in the space. The way I like to think about formal verification, it's not necessarily for Web3, it's actually something that a lot of people, in particular, I'm pointing out something which actually written by Ernesto from the BGD from Aave. It's a mechanism to help you to feel more secure about your code. So the idea is if you work in, basically you look into a grid, you have the protocol, what the protocol knows, and what the hacker knows. And with auditing, it helps you finding blind spots, it helps you finding situations in your code that you are not aware of. With formal verification, if you have the right specification, you can also prevent unknown attacks. So it's increase your trust in the code. Of course, it's not perfect, but it's increase your trust in the code. You probably had 2 weeks ago the big story about Pavel, the Telegram, and did you see how Vitalik reacted? So this is the reaction of Vitalik. I'm not sure I agree, but still it's interesting. So basically the idea is that formal verification, it's increased the trust in your code. So you can argue that once you did formal verification, you have a little bit more trust in your code. So how does the formal verification fit in the verification process? You can think of essentially writing in your program twice. Once you write at the top, the normal DApp, you write the Solidity code or Rust code. Certora now support actually the EVM and bytecode and others. And you go to the audit. That's the top one, you basically the normal process. But there is a process that you are doing in parallel, that you are starting by writing some requirements. You can write them in white paper, you can write them in a formal way. You are writing more requirements on your code. And this increases the trust in the code. And you can use these requirements for doing testing. You can also formally verify them using our tool or other tool. And then all of it, when the code is deployed, it feels more secure. And you can see, and actually Jochen will show that we have proved interesting property of the Uniswap v3. I think sorry, v4. So maybe I want to sort of give you the hint of it for those who are not. So the interesting thing about formal verification that actually, and this is of course something that people have done, not just in Web3, for example, improving correctness of compilers, improving correctness of hardware architecture and avionics software. So the idea is you can prevent some bugs which are very rare. So this is actually looking from Euler Finance. This is the bug, famous bug. And it is a bug which is potentially tricky. And what you see here is actually very interesting specification that the Euler team came with. And they call it basically Holy Grail. So it's a specification that somehow say, how is a lending protocol behave? And you can think about it some kind of a stability. And the idea is that you go in a protocol and you can actually not move from healthy to unhealthy. So you always stay healthy. So this is a bit technical, but I saw the presentation of Alice and everybody, so I see that you guys are very, very technical, probably more than me. So this is essentially like writing in Solidity. This is what you do when you write specification. You write it in your own language, which is called CVL, And CVL is like Solidity. It's almost, you see that it actually looks like Solidity, but it has some weird things that we use essentially to access the virtual machine. Also, it has the ability to call arbitrary function. So we are essentially, it's some kind of a verification harness. It's some kind of things that you tell the system what you want to verify. And in this case, you see that the property that we want is every function that we call, it can never go from healthy to unhealthy. And it's a very tricky function, and actually the code is pretty tricky. And it takes the proof a long time, probably 3 hours, but within 3 hours, it's actually able to verify that. So it's able to show, it actually make you more confident about this code. So formal verification, as I said, it has very rich history, and like AI and many other fields in computer science, it has good and bad periods. And it's very interesting. Formal verification actually goes all the way to Turing, which invented computer science, actually, and invent the Turing machine. And actually, after him, we have the Turing Award, which is the most distinguished award in computer science. So in his first paper, he said that formal verification is hard, which is actually the case. And then you see there are this golden age where all these people, very, very famous, Robin Milner from the UK, Tony Hoare from the UK, Edgar Dijkstra from Amsterdam, Patrick Rousseau is actually here in NYU, and Robert Floyd from Stanford. All of them, they sort of contribute key theoretical techniques to do it, and everybody thought that formal verification would be used by everybody. And there is a quote, I think it's a terrible quote by Dijkstra, who is one of the most genius people, and he say, you cannot use code unless it's formally verified. And I think it's completely nonsense. But anyway, this code says that you have to formally verify the code. And what happened in 1979, there was this very interesting article. I recommend reading it by 3 professors from CMU, essentially explain why you should not use formal verification. And actually, this started a lot of what we call the dark period in this space because people thought it's not the right thing, it's complex, it's expensive. And this is actually where I came into play, where basically many people, including myself, have developed engineering techniques that make formal verification used by everybody. And sort of we see that in Amazon, we see that in companies, so a lot of people are using things by everybody. I want to point here the very nice quote by Bill Gates, where he basically say about Microsoft being able to verify the device driver, so basically showing the device driver cannot have a blue screen because the device driver are written by external code. It's very interesting. Of course, I'm a bit biased because it's based on algorithm which Susan Horowitz and Tom Webster and myself have developed. And there are a lot of open source tools, and there's our free tools, so there's a lot of tools to do formal verification. I want to be short to let the people talk about more technical things. So maybe for those who are not doing the competition, I want to somehow come up with 4 things about formal verification. So the first thing about formal verification, every time you use formal verification, whether it's in Uniswap or in any code, you have to have some level of paranoia, okay? And I think there is the nice quote, which is sort of the opposite of Dijkstra, by Knut, which is one of the most famous computer scientists in Stanford. He say, I only formally verified the code, I didn't test it. It's probably not a great idea, okay? I'm not recommending it. I'm not recommending it because there are limits. Of course, for example, how do you know that the specification is right? Okay, so formal verification, it does not produce a bulletproof code. There are a lot of things that can go wrong, but it does increase your security, and it's reduced, but there is some kind of trust thing. For example, even in the proof that we did for Euler, we trust something about the price doesn't change so much. So there are certain things that we cannot formally verify, and it's not just technological limits. The other thing that people say, and they come to us all the time, they say, oh, we want formal verification instead of auditing. That's completely nonsense. Okay, you need formal verification in addition to auditing by us or by any other team, because auditing or any kind of code is very good when you have a lot of things. The other thing is that formal verification, actually the most useful use of formal verification is to start as early as you can, even before you have the code. We recently actually did a project with Lido. We actually did reasoning, actually, Jochen here and Tomer, we're actually in open source system, and we find bugs in the design of the dual governance before they wrote a single line of code. So one of the things our auditors say, they are complaining that we prevent them from finding bugs in the code because we're finding them early. It's a good idea to find bugs early. We want to find bugs early. The last thing about it, especially for people who want to participate in competition, it's not as hard as you think, and it doesn't require a PhD. I heard our competitors say that, no, you can do it. We have, and if you see, and Armin will show, some of our competitors, we don't know, they are newcomers and they do a great job. I think I'm good. I think, so Jochen, you do something much more interesting.
Yeah, as an example, I wanted to show one property that we showed for Uniswap, and this is a property, this unlock mechanism that if you use a contract, you first have to unlock the contract, and then you can call arbitrary functions on this. And every function can basically give you a debt to Uniswap, or it can give you some tokens on Uniswap that you have to take. And you call them in arbitrary order, and then at the end you have to go back to the unlock function because you were called from the unlock function, and yeah, every function must return, like a flash loan. Basically, at the end, the unlock function checks if the currency delta is now 0, and then it reverts if it's not the case. And basically, your whole transaction is reverted. So this secures the Uniswap contract. You can't make debt and keep them in the contract, but you have to settle all the debts at the end of the call. And yeah, this is a property that we showed. I think this was the first property that we showed for Uniswap v4. And one important thing here is that the currency delta is 0 is not actually what the code contains. The code checks if the non-zero counter of all the currency deltas is 0, because there are arbitrarily many currency deltas, and you can't just enumerate them and check them all. So there is this non-zero counter. And this is our strong invariant that we proved. So if the non-zero delta counter is 0, then all addresses, so all users and all tokens, there is no outstanding debt or no outstanding balance on the Uniswap contract. And this is a strong invariant. And an invariant for us is something that should be preserved whenever you call a function of the contract. So we check with, we automatically generate rules from this, so that assume that you are currently in a state where this property holds. You call an arbitrary function, and then you prove that the property still holds afterwards. And this is a bit simplified. We needed a few auxiliary variables because you also have to say what happens if the non-zero counter is exactly 1 or exactly 2. And we basically had some very complicated code that I don't want to show here, but this is a property that we showed in the end, that if it's 0, it's no.
How is it that your for all loop can enumerate currency deltas?
Yes, interesting question. So we first we can build hooks. So whenever you write to an array, we get notified. So with the CVL language, we can basically hook ourselves into the EVM code. And whenever you write some value in the array, you get a function that is called on the CVL level, and you can update your data structure. So you know which values are 0 and which not. And the other thing is we can write, we have a for all write operation. So we can write into all elements into an array at the same time. But this is really advanced topic. Yes? Yeah.
Maybe my understanding is wrong, but when you say formal verification and you want to exhaust all possible values for all of these, for example, tokens, addresses, all I can think about is just, do you do any kind of, how do you do that? Is it interval arithmetics? Is it how?
It's a very good question.
Intuitively, how could it possibly be?
So, yeah, in mathematics, it's for all. If you have for all property, you need to show it for any value. So we pick an arbitrary value and then ask the solver, can you prove it? And yeah, it's also for the inputs. In this case, you can immediately say that everything that wasn't touched by your code, the invariant doesn't change. So you only need to look at the values that were touched in the code. And this is what the prover in the backend will do for us. So we use SMT solvers to prove these properties. And they will already determine that for an array, for example, it doesn't change at any position except the ones that are occurring in your code. So it only needs to check these positions. So it will ignore any user that didn't call an instruction here. And since we look at one run through one function, we have only finitely many of them.
Do you have a document out there that we can read about it, familiarize ourselves with the underlying methodology that used how do these proofs work actually? What would you recommend? Any source?
I did a lot of research.
The white paper is probably stuff, right? The white paper.
Yeah, I mean, if you really want to,
Not this complex thing.
Yeah.
This is stuff. We have a white paper on our website. This is strongly backed, not Certora.
yeah, I mean, we also have tutorials on the website. Yeah, but
And I think there was a webinar on the Uniswap code authentication earlier, which is recorded.
No, but that's about using the tool. No, I mean, what is the underlying proof mechanism?
Yeah, so it's based on SMT and it's the white paper will explain.
if there are no questions, then
Okay, thanks, Johan. I'm going to go into why you should participate in the contest. This is the last contest we did. So you have a big pot, and if you find severe bugs, you get a lot of rewards. But with formal verification, you just have to prove properties, and it's also, you can find bugs by proving properties, or you can just prove them, and if you prove them, you still get some rewards. So these are some numbers from the last contest. I think the top guy earned 28K, and the top three from formal verification earned around 20K each, with a much smaller pool. So I think a good place to put your time into, and it's potentially interesting to learn new things and get started with that. So I'm going to give like a quick 10-minute overview of the contest repo, just some stuff that we've done. Since we have verified v4 core, there are some properties that we assume. The contest for the formal part is for periphery. So when there's external calls to core, there's assumptions that we make about the contracts that we've proven. And then I'll just give you a quick overview of the layout. When you scan this, you go into the contest repo. There's a README there with all the information you need to participate, how to submit, how much the rewards are, how to do everything. I suggest reading it. It's not too long. But yeah, so this is the repo you'll land into. You have some scope stuff. You have some information about getting started, guidelines, blah, blah, blah. And then the main thing that's here, the setup is, I don't know how big this is. Maybe you need it bigger. Is this Certora repo. You could see there's some folders here. I'm just going to give you a quick overview of what's here, and then you could dive into it on your own time. So the confs are the configurations for the tool. These are telling the tool, the settings to use, what file to look at, what specification to look at. The harnesses are additional contracts that we use. They usually implement the main contracts. They add some additional functions that are helpful in the verification. Mutations are used to evaluate the specification, so there are bugs in the code that we inject. There's only a few here, and then there'll be the ones that we actually use for the evaluation after the contest is over. This is just for you to kind of test and start participating. And then there's the specification, which is where you'll write your invariants and your properties about the code. So just a quick overview here. I'm not going to go into this, but these are like the files that are in scope, and then you tell it what you're verifying. So this is the spec file, this is the contract. Not going to go into that too much. There's some harnesses which I'll go into, and then there's a lot of stuff in the setup that I'll just touch on briefly. So the main two contracts that you're going to look at are the position manager and the v4 router. You have a harness for both. We do some things in the harness that make the verification possible, or at least more fluid. So you have the handle action in the normal contract that you call. So we actually just make all the functions just external. And whenever you're approving a property, let's say you want to say, after a settle, all the deltas are 0, you can just, you start an arbitrary state, so you can call settle directly. Things like multi-call and handle action have a lot of switch cases that are complicated for the tool, and you have something that's basic that will take like 20 minutes, and you get the same effect by just calling the functions directly. And since we're starting at an arbitrary state, you basically cover all your bases. You're not simplifying anything. If anything, you're proving something stronger. Anyway, so yeah, these are the functions that you call. You can see this is the harness, the main contract. You were doing the same thing for the v4 router. You just make all the internal functions directly accessible from the specification. You could see this is the specification. This is an example rule. I'll go into briefly, but it's not too interesting. It's just more of an example. If you get started, you could see how to call functions and things like that. Yeah, so I guess just a quick example. Like for example, here you're calling increased liquidity. That's a function in the harness. And then you have some internal getters that I'll show where they're defined. Yeah, so these are the two main specification files. This is where you'll write your formal specification. They import files from the setup. This is the main thing I'm going to go into. So I'll start with the most complex one. This is a mock of the pool manager. Since I mentioned that we're verifying the periphery, so the core contracts are summarized. We assume some properties about them that we've proven, and then you're free to also add properties as you see fit. So you can see all the external calls that are made in the periphery to the pool manager. The core contracts are summarized with the mock functions, and you can see we have some storage variables that we update in the mocks to keep track of everything. And I'll give you some example of like what we're doing here. For example, in modify liquidity, this function looks pretty similar to the modify liquidity in the actual pool manager. It's just much easier for the prover to handle. And then at some point you have these variables, which when you initialize them like this are arbitrary. And then this is where you need to make some assumptions, some properties. Sometimes you can prove something about the periphery without making any assumptions on the core. And sometimes you need to make some assumptions. An assumption might look like something like this. You can say, if my liquidity delta is positive, then my principal amount should be negative, and vice versa. So, maybe you're trying to prove some property, and then the counterexample breaks this assumption, and then you would require, because it's true about the pool manager, and then so yeah, you would edit these conditions functions, which are inside the mock functions, to add any assumptions that you need to make. And you can see these are calling, for example, like the set currency delta and get currency delta. Those are defined here, where we have some variables for them, and you could see how they're defined. You don't need to dig too much into here. This is just for your use. But yeah, it's basically just to summarize the external calls and make them still accessible within the spec. There's the conversions spec, which helps you just do some basic conversions from the pool key to the ID and vice versa. This is some math summarizations that are equivalent sometimes and sometimes over approximations of math that you can use. These aren't used currently, but you can use them. I think that's most of the, yeah, and you also have this auxiliary, which does some, gets you some values and returns some variables which might be useful when you're verifying things like, gets like the pool variable and returns an arbitrary bytes 32 if you need that. And then we also use a mock ERC20. This ERC20 is just like a normal token, but everything's implemented in CVL. It's equivalent to using a normal ERC20, but yeah, much easier for the prover to handle. I think that's a good brief overview of the specs. As I said, in the harness, we have some functions made external. In conversions, yeah, you have some conversions, as the name might suggest, from currency to currency. Sometimes you need to use an address in the specification. And this is a nice way for you to be able to do that if you have a currency instead. And then it also imports some types that are used in the specs. So for example, most of the, most things are defined based on currency, like most types. Sorry, it's conversions. Yeah, like currency, or I think there's some data one too. I think that's most of the setup. Again, yeah, I know it's kind of fast and a lot, and I don't know if you guys are all that familiar with CVL or formal verification, but hopefully people can watch the recording, or if you're interested, you can watch it later. Yeah, any questions? Yeah.
Would you say Uniswap V4 compares in complexity to other large systems that you've done that field, like Locket, for example? Is it harder? Did you have unique issues?
I'm not too sure. I've mainly worked on this setup. I think it seems like, maybe Johan can say, to me it seems like it's nice and modular. Like you can have the core, and you can, we've proven about the core. There's some interesting properties there. Like you can say, if the deltas are 0, then you must be locked, or these high-level properties that you can prove that are very useful. And yeah, like it's semi-modular where you can have the periphery and you can assume things that you've proven about the core. Maybe Johan can say more.
The question was, what was the question exactly?
How does Uniswap V4 compare to other similarly large and complex systems? Do they formally verify? Do you have any unique challenges with V4? Any new learnings about the tool?
I mean, this V4 core was very interesting because of the pooling of the funds. So you have to reason. There is not even a variable that tells you how much should be in the pool. You have to look at the positions, and then from the position you can compute with complicated formulas how much should be in the pool. And but it's never recorded in the contract itself. And this is very challenging. So we actually looked at the total liquidity in every tick range, or even in every tick, and proved that the funds that we need there, or the change if you add liquidity or if you swap, corresponds exactly to the values that Uniswap computes for the swap and the add liquidity function. So this was a very unique challenge for Uniswap. Yes, I mean, they are quite new. We even implemented it somewhere in April or May when we started, and we had to come up with new rules. For example, for invariance, we now need to show that the invariance still holds if the transaction is over, because suddenly your transient storage gets zeroed out.
Did the unlock, like cash accounting mechanism, make it easier to formally verify or more difficult than more traditional?
I think the big advantage of the unlock mechanism is you don't need to reason about too many calls from the Uniswap contracts. You still have the hooks, but at least you don't need to reason about what the transfer function can do, except for the take function that calls transfers.
Yeah. I'll sit. Gotcha. Yeah, this is just.
Maybe we should be larger. Yeah, I love that. I want to be more.
Yeah. Cool.
Yeah, I know, right? I know it's right.
So, yeah.
Somebody else, let's just test everything first.
That's right. Your laptop's about to die.
We can also, I'll get you a charger.
Cool.
You want to-
Yeah.
If it dies, it dies. It's not necessary. It's just intro.
Sweet.
I'm looking at this, it says. Like a spot check?
Yeah, like the single.
It definitely doesn't seem like it's on. Oh, my eyes.
Testing? Hello. Do you each want to test your microphone?
Testing, testing.
Hello, hello.
Hello. Hello.
Hello. We've got an informal panel. I have some questions. We'll take some questions from the audience. Uniswap v4 has been audited so far by 5 audit firms. We have representatives from 4 of the audit firms here. The final firm was ABDK. And every audit firm found at least some issues that other audit firms did not find. So every audit provided us with additional value over the others, which was really interesting to find. And yeah, it's been really awesome working with these companies. They've all been super thorough, really helpful answering our endless questions, probably going beyond what we actually paid them for, reviewing extra fixes, going over and over again, lots of things. So it's been really awesome to work with these companies. Do you each want to introduce yourselves?
Sure. I'll go first. I'm Kurt Berry. I'm an independent security researcher. I'm a lead security researcher at Spearbit, and I used to be a protocol dev at the protocol formerly known as MakerDAO.
My name is Jochen Hönicke, and I'm doing formal verification for Certora. Yeah, looking into formal how to specify the properties that we want to verify. And I come from academia. I did program verification before and wrote my own SMT solver.
My name is Jose. I'm based in Spain. I studied as a white hat engineer, and I've worked as a security researcher for OpenZeppelin for the past 2 years. I audited Uniswap X last year, and starting this year, I became a technical manager. So this year, I oversaw the audits for V4 Core and Periphery, which was quite awesome.
My name is Benjamin Samuels. I'm a senior security engineer at Trail of Bits. I specialize in node software and stateful fuzzing with tools like Echidna and Medusa.
Awesome. Quick fire first question. I'd like to know each of your favorite things about V4.
All right, I'll go first, fine, if nobody else wants to talk. I think my favorite thing is seeing the interplay between all the different design constraints. So it's trying to be very featureful and powerful, but also secure and also gas efficient and also ship in finite time. And you see all these cool little design decisions resolving those, like, you know, for example, the kind of hook flags being embedded in the address, if the pre-mine your hook address for the permissions you want, and, you know, many other small examples like that.
Yeah, my favorite thing is actually the one that I showed, the new unlock mechanism, which is basically, yeah, the first time I saw it, it was quite confusing because it's the opposite way that you are used to locks. You can only use the contract if it's unlocked. If it's locked, if it's unlocked, you have to first log it before you can use it.
For me, it's the huge flexibility and customizability that the new pool manager as a singleton offers. The fact that you can do any action that you want in any number of times in any order, and also you don't even need to actually transfer tokens in and out. You can just use the awesome ERC6909 system. It's great. I've done my fair share of arbitraging in the past, and I know how important it is to shave off those extra 1,000 units of gas. So I found that brilliantly designed.
For me, it's going to be the hook system. At first, I wasn't quite exactly sure where it was going to be like helpful, but then I thought back because there's so many protocols that like have to implement some kind of AMM. Like maybe you're making a perps protocol, maybe you're doing an AMM but with a twist, and those people basically have to start from the bottom up, and that sucks. They shouldn't have to do that. But with the hook system, like you could really just build it on top of Uniswap and just have your hook and have a whole protocol in there.
Nice. I realize it'll be unfair to always go in this order, so I should mix it up sometimes. Okay. If tomorrow, well, I guess it wouldn't come out tomorrow. If at the end of the contest, it gets discovered that there's been a critical vulnerability missed by these audit firms in V4, where in the code would you most suspect it would be? We can start with Ben.
Probably in the periphery code because I didn't look at it. But actually, though, it's the sync and settle stuff. That's where the most issues have been so far. And it's really tricky to understand how it works thoroughly. And like when you're auditing this, at some point, you're going to think that there's like a critical bug in sync and settle. You just are. And you're going to spend 4 or 5 hours triaging it and realizing that there isn't a bug there. But maybe there is. It's still probably the part that I'm least secure about.
I agree with that one. That was my first choice. The second one would be the subscriber feature, since it's a brand new one. It looks flaky, even though then it looks, it is solid. We tried very hard to break it. And yeah, it's something novel, so we're still not sure how it's going to integrate with other protocols. And also slippage checks and fee accrual. I would focus on those.
Yeah, I think I am also with the ERC20 interface and also with the hooks. basically everywhere where we don't know which code we are calling, we can't imagine what will happen if someone tomorrow will write a new token that has a new mechanism that will break the invariance of Uniswap.
Yeah, I mean, this is interesting because it's specifically a critical bug, not just any bug. I mean, yeah, I can't disagree that there's a high probability of bugs, for example, in Periphery because it's newer, or in the sync settle mechanism because it is so subtle. I don't know how likely it is those bugs are going to be critical. They certainly could be. Like if there is a very deep critical, for me, it might almost be in the swap logic, some sort of very weird rounding edge case that, crosses a tick without actually doing the cross tick update. And it, only happens because there's this weird rounding error that has never been hit before in the explored state space. So that's my dark horse answer.
That's fair. I remember on a call you saying you pointed at one particular line of code that was your one scariest line of code.
Yeah, it's using basically a floating point function to determine discrete value where it's going from a price to a tick, and that just scares me just from a fundamental principle of the matter.
That's fair. Yeah, and I don't think we talked about this today, but because pools can be specified with any fee tier and any tick spacing, they're using the same maths as Uniswap v3, but in a way that it's never been used before. And so that was one of the main things we flagged to all these audit firms when we had our kickoff calls of what scares us the most. It's we're using this very well-tested v3 maths that's out there and it's been used for years, but we're using it in a new way. And is it still going to withstand all these new types of pools? So I agree that scares me a little bit. What should we talk about next? Are there particular areas of the code base that you thought were more robust, or you felt it was easier to conclude that there were no issues, or easier to conclude that it was unlikely that there were issues in there? Because I know when you're auditing, there's certain contracts where you end up spending the vast majority of the time looking at specific few contracts, and other contracts where you're this one seems like it makes sense. Jochen?
Yeah, I like this apply delta functions where you basically, if you have a normal AMM and you swap, you always have to reason when do you call, when do you send the tokens, when do you receive them, and here you just have this atomic function that is inside your contract. You have full control over it, and you only have to reason about that, and then you can separate the reasoning of the other functions.
That's interesting. I hadn't thought of it like that. Jose?
I've been thinking about this question for the past couple of days, and I don't think there's a section that you can easily conclude that it's safe. But if I have to choose one, it's what scared us the most at the beginning, is what you just mentioned. It's the fact that v3 math is super solid and battle tested, and here it was just ported, so it seemed fine, and it was kind of out of scope, but at the same time in scope, so we did not have enough time to check it. But once we ran at least some differential fuzzing on both libraries, we were quite satisfied with the result and were able to move on.
Nice.
Yeah, +1 on the v3 stuff. It's that code has already been out there, it's battle tested. And the things that we're going to change, the inputs that we're going to be now showing up in this code that it didn't experience before, were very tightly defined. So as soon as you look at the v3 code and you verify it can deal with this, this, and this, it's okay to move on. And the one thing that was kind of challenging with v3 to still think about is a lot of the Solidity code was converted to the assembly language YUL. So, I mean, if you've got differential tests for that, if you've got a formal verification test or something, or a fuzzy test for that, then you're pretty good.
Yeah, and we also converted it from Solidity 0.7 to 0.8, which changed a lot of maths properties between the two. Maths became checked. So we had to convert anything that was using safe math previously to regular math now, and unchecked and regular math previously to unchecked maths now. So that was also a translation.
Yeah, I'd echo a lot of things that were said. A lot of the code that was kind of copy pasted with just adding an unchecked block or converting things to assembly was, so long as you checked that those conversions were correct, you could be confident. A lot of the lower level libraries were very simple, and you could, review them and say, okay, this is a simple object that behaves in a way I expect. But, there was no non-trivial flow through the code, or like actual large contract that I thought was easy. You know, everything is pretty complicated, other than like some of the individual pieces. And so, you know, fun challenge.
I'm glad it was fun. Okay. So one thing that Sarah and I struggled with, particularly for kickoff calls, was we've obviously thought about V4 so much that it's really hard to describe V4 to other people from scratch. Like, where do you start? We tried to do it this morning as well. It's hard to explain something you already know so well in a way that other people are definitely going to understand from zero. And so we tried to give you each a walkthrough of the code base or various knowledge, or there's a white paper to read. But I'm sure there were some things that we failed in. Was there anything that you wish you had known at the beginning of the audit that you discovered as you went along that it would have been easier to just know it from the beginning? Niche question, though. Maybe you don't all have answers. For example, maybe these people want to know it now that they're kicking off auditing it. Let's start with, I can't remember who I've started with recently. Jose.
All right. All the presentations you gave us on the kickoff calls were golden. I'll give you that. That accelerated our knowledge acquiring. But there was one thing, the team lost quite a bit of time in the beginning on periphery, and it was the fact that they were thinking that money should flow through the router and then into pool manager, because they were used to money flowing out in and out of the router in V2 and V3, and that's not the case on V4. So that realization came a little bit late, and it would have been nice to know about it beforehand. But apart from that, all good.
Interesting. Because the money flows through permit 2?
Sorry?
Because the money flows through permit 2 instead, or?
Because they were thinking that the money would go to the router and then to they just had the mental framework from V2 and V3.
Yeah, that makes sense. Yeah, the money goes directly from the integrator to the pool manager.
Exactly.
And like, except in like edge cases. That makes sense. Ben?
Sure. So there's a lot of conditions under which V4 isn't supposed to actually operate. So if you have a token with more than like, I think it's 2 to the 128 total supply, like it's not expected that V4 is going to work for that. And there's a couple other assumptions like that in there as well, where you would expect a swap to work, but either because the total supply or something's wrong, it actually reverts. We had to spend a little bit of time at the beginning trying to iterate and figure out what all of those assumptions were. Another thing that we I don't think you could have ever told us this, but when you're doing an audit, like there's this balance of exploring the code and understanding it and then trying to exploit it. And I think during our engagement, we trended a little bit too much towards trying to exploit it and not enough time trying to explore it. This code is like really complicated and it looks fragile, but it isn't. It's very easy to accidentally spend way too much time trying to exploit it without having a full understanding of how it works.
Wow, interesting.
All right, we overflow now?
Yeah.
We wrap around.
Overflow.
And you know, honestly, the materials provided were very good, and like details, like write-ups, like the design decisions behind hooks. Honestly, I would echo maybe some of the like unstated assumptions like this. You know, we're assuming that tokens don't have total supply greater than an amount. And I mean, one small thing that I'd add that tripped me up a little bit is that some of the libraries in core are used as well in periphery. And initially we were only auditing core, so we were finding things like, this doesn't necessarily make sense in core, this code path can't be used, why does it even exist? And then later when we audited periphery, it's like, oh, there's that code path being used, and I had to go back and like delete my comment or whatever. I didn't delete it, I just made a note of like, okay, I see where this is used now, but you know, keep that in mind as you're reading core, is that some of those libraries are meant to be used in other contexts, and if you find a code path that's not used, it maybe just is not used in core, but elsewhere.
Yeah, I got that comment recently about the V4 router, because you open it in periphery and it's like, where this isn't used anywhere. It's an abstract contract that's never used, and it's used in another repo. So that's a good point. Jochen?
Yeah, this was the first audit of Uniswap for us at all. So
Okay.
we didn't look at V3, and there's a lot of things that you probably take for granted. What exactly is liquidity? What is square root price?
Right.
And this was a bit of a learning curve.
Yeah, in at the deep end, going straight in with V4, for sure. But in some ways, it might have helped you. I think one thing we struggled with is because we have certain assumptions around V3, you have to try and doubt everything. Like, yes, it worked in V3, but you still have to assume it could be a bug in V4. And so maybe in some ways, it's also helpful to ignore all the prerequisites of V3. But it is a lot to learn in one go, definitely. I don't know. Oh, near misses. I liked this suggestion. Were there, maybe you've somewhat covered some of it, but was there a bug that you were sure was in there and you spent a while digging into it and it turned out there was some check or some reason that it wasn't actually a bug, but you were convinced for a while you'd found something?
I mean, there was one thing I got a little bit excited about, which is in modify liquidity. There are no kind of like upfront checks that the ticks are aligned on boundaries. And so then I started like digging down through. I was like, why is there like, this seems like an obvious thing to check. Like you shouldn't be, writing to ticks that, aren't on the boundaries. Like, why don't you just check that as the first line? Well, I dug through. Anytime you're actually changing the liquidity, you go down like 3 or 4 libraries deep, and in some assembly code, there's, I think it's the flip tick function in bitmath is actually enforcing tick alignment if you have non-zero liquidity modification. But if you have zero liquidity modification, right, it's still a poke. You can collect fees, and it doesn't go into those flip tick functions. And the way it gets prevented there is because there's a check in, I forget which function it is, but it says you can't poke positions that have zero liquidity, and because of the checks in flip tick, only aligned ticks can have non-zero liquidity, and so it was actually like quite subtle how it was never possible to do bad things to misaligned ticks, but ultimately it was not a problem.
Wow, I don't think I could have told you all of that off the top of my head.
I reviewed it before.
Yeah. Amazing, Jochen.
Yeah, there was this, there's this ESE 6909 token where you have a UN256 for your token number, and this is a bit longer than the address. And there is this subtle bug that you can just mint this token or settle to this token and keep the high bits different than zero. And this basically brings you, gives you multiple accounts for the same token in the contract. But it still works out because if you sync one token, then the balance is already updated and you can't sync the other equivalent token again.
Nice. I remember, I think it was you guys that brought that one up with us, and we have now made it so you can't do that. Even though that wasn't necessarily a bug, it was weird. Nice. Jose?
We also went down that rabbit hole, wasted a lot of time over there. But we also spent, and we're kind of sure that we were going to break it, the subscribe, unsubscribe, try-catch block. We were looking for any chain that you could still self-destruct so that you could crash that try-catch block, but eventually we did not find anything since it's been deprecated everywhere, and we had to move on.
So when you're initializing liquidity, when you're initializing a pool, you don't have to add any liquidity to the pool. And you can set to whatever price you want. And that really tripped us up because you could set it to any price up to the maximum square root price and between the minimum square root price. And depending on your tick spacing, that price that you set might actually be above the upper bound of the allowable tick. And we thought there might be something with that, and it was a huge rabbit hole, and we spent way too much time on it. But it's like the first swap through the pool is going to fix it, so it doesn't really matter. There's a lot of rabbit holes where like you're going to look at a function and you're going to be like, oh, wow, this is totally something I could break. And like was said earlier, the thing that actually verifies that that isn't going to break is really far away in the code. It's deep down in a library. It's deep down in like bit flip math or something. It can be, try to optimize how fast you're going to be verifying these things, because if you spend too much time on it, you're going to spend your whole engagement just trying to verify issues.
And to defend the code slightly, I mentioned the constraints earlier, right? Like having those checks buried where they only get invoked in very particular instances of saving gas on every other call where you actually wouldn't really need to check it because it can never happen in the first place. So it's in line with the sort of balance of constraints, but so I don't want people to think the code is just bad because of that. They did it for a reason.
Yeah, it's done for a reason. It is a little bit scary though, I see that, because if we then change something at a library level, it's hard to see like all the ramifications it can have all the way up the stack. But that's why you have lots of tests.
Be warned, forkers.
Pardon?
Anyone who forks, you know how like people
Yeah.
fork protocols and then they screw it up and they get hacked? If you're thinking of forking V4, just know you're probably going to get hacked. Like it's true.
Build a hook instead. Yeah, I think even if I forked V4, I'd probably mess it up. Nice. Okay. Was there any techniques you used for V4 to help you verify whether a bug was correct or not? Or something around that? Ben?
So for most of the engagement, I was working on our stateful fuzzing harness, which involves working with their test suite, working with the fuzzers. It's very easy to build a POC when you're down in the trenches trying to like fuzz the code. We got a lot of value in using the actions router class that's in the test suite. You really want to optimize on being able to write up a POC really quickly, test it, verify it, make sure it works. Yeah, that's probably the best advice I've got.
Nice. Shout out Sarah for writing the actions router. It's a, for context for people who might want to use it for proof of concepts, it's a test, it's a contract we have that we only use in tests. Much like those command-based contracts we ran through earlier, it's a command-based contract that also allows you to do, you can basically write a test with any succession of actions and checks. So you can sync, and then you can get it to look up a certain value in the contract and check that it's correct. And then, and you can add new, I'm sure you guys probably added new commands to do extra checks. And so we use it often to like pull together a quick test of, oh, what happens if you do sync and then settle and then another settle of this thing and check that values are correct in between. It's like you can chain together these actions in any order. We also love it. Right, Cut?
Yeah, I mean, I've got to echo, you run the tests, be able to modify them, leverage the infrastructure that's there, because it'd take you a long time to write it yourself. As far as verifying bugs go, I mean, whenever I'm trying to verify a bug, I'm always trying to like find the reason it doesn't work as quickly as possible so I can move on to the next thing. So that's maybe just a more general strategy of, okay, how can I prove that this is safe? Like, what's the quickest way that I could convince myself it's not safe? If you keep convincing yourself that it's wrong, it's more likely that it's a problem. And I think that is especially relevant on very mature code base like V4, where it's actually more likely you haven't found something. So you want to try to prove that it's like think I'm going at it like I'm going to prove it's safe rather than, okay, it's definitely a bug, I'm writing an exploit. And sometimes that'll get you an answer quicker.
Interesting. I like that. Jochen?
Yeah, I'm in the formal verification guy, so I don't write the exploits. I just say this could be interesting. Anyone else wants to try it out?
Nice.
But yeah, we actually don't have the problem with trying to prove it's safe, because if it's safe, we don't even see this bug. We get a context sample, and then we need to figure out if this is prevented somehow.
Okay. So yours is like you get a rule that breaks and you have to figure out if it's a problem with the code or a problem with the rule.
Yeah, so if this edge case is really allowed or not.
Because you can also have over approximations, right? Which is where the prover can say it's a bug, but it turns out to be fine, right?
Yeah, of course, the provers also sometimes over approximates.
I remember early on you coming to us with something where it was a rule that had broken, and it was because you were running you were converting our fuzz tests into formal verification rules, and there was one that was breaking, and it was because you were using our test router, which for no reason at the end of every transaction sweeps extra ETH back to the user at the end of the test. And because the formal verifier was just like seeding the contract with ETH, the user was ending up with way more ETH than they were meant to or something. And so it was actually down to our test contract having not quite a bug, but just like a strange behavior that was breaking a rule. Jose.
Well, not much to add to what everyone said. We did a lot of fuzzing, and the test setup that you had was quite helpful to do that quite fast. And apart from that, what I said in the beginning, differential fuzzing to V3 libraries and V4 libraries to make sure that the outputs were consistent.
Nice. I feel like we've covered a lot of this. Even the ones I haven't asked, we've like, any particular things you want to talk about? Or I can turn it out here. Oh, wait, no, we haven't talked about this one. Can you talk about one of your favorite bugs that you found? A real bug. There were lots of them. Who wants to start? Jochen. Am I saying your name right?
Yeah. Yeah.
Yes. Okay.
Yeah. So I think one is the one that we discussed that wasn't really a bug. This
That was
M2,
a good one.
which basically is the price doesn't need to correspond to the current tick exactly, so it can be even the next tick. And other things were these inline assembly code where it's a potential bug if the next compiler version changes the behavior, like initialized high bits or using memory locations that are reserved by the compiler.
Nice. Yeah, I think Certora M02 is probably the issue that caused us the most stress internally. It took us maybe 6 weeks to conclude that we weren't going to make any changes. And we wrote a fix. I wrote a fix. A girl on the team wrote a fix. Someone on your team wrote a fix. And for all of them, the formal verifier said we were still wrong. So eventually, we've ended up concluding that we're not going to redo the whole swap function to fix this issue. But it's an interesting one to dig into. Certora M02. It's going to be with me forever, that one. Jose?
Well, for me, the favorite one and the one that I want to discuss because of the underlying reasons was the critical found on core, although Sarah front-ran me earlier with the description of the issue. But this double entry bug was I wanted to talk about the thought process we had in order to figure that out. The first one being the multi-chain nature of Uniswap. It's deployed basically everywhere. And it used to be enough as a security researcher with just checking whether push 0 was available on the other chain or not. But nowadays you need to be up to date with multiple nuances on and behaviors on different chains. And sometimes it's actually hard to keep up. Some precompiles may work differently on CK-Sync era. Some tokens may have this double entry point, and you need to be aware of that. So that was one source of thinking. And the second one was sometimes when you have a very flexible and complex project such as Uniswap v4, there are numerous ways to do things. And whenever there are 2 or more paths to do the same thing, we dedicate quite a lot of time to make sure that they actually do the very same thing. So we found that you could actually settle the native currency, or you could actually settle through the ERC20 contract address. So that's 2 ways of doing different things, and the logic was quite different. And combining those 2 thoughts, that's how the critical span out. And it's something we should all have in our tool chain every time we audit a multi-chain project.
Yeah, definitely. I feel like it's so valuable to have a list of weirdly behaving tokens that are still like valid tokens. There's lots of weirdly behaving tokens that we would just ignore. Like there's an owner who can just take everybody's tokens from them. Like we can't protect that, but something like a double entry point and stuff like that is rebasing. There's so many strange tokens out there, and some of them work on V4 and some of them don't.
To add a little bit more insight on the double entry thing, we identified 3 tokens. One was the Celo token, the other one was Matic on Polygon, and the third one was actually ETH on CK-Sync era. And we could manipulate deltas on the three of them, but we could not call take and actually withdraw and drain the pool in CK-Sync because it doesn't have a transfer function. It's really not an ERC20 compliant token, just a contract. And on Matic, there's a check enforced where it checks that the amount you're transferring matches message value. And in that POC, it didn't work out, only on Celo. So interesting insights.
Yeah, super interesting. Nice. I can't even remember who we've spoken to. Ben.
So my favorite bug is the one with syncing and collecting protocol fees. It's a low bug, and like realistically, it's not something that would actually get exploited in the real world. But it's a flaw involving two parts of the code base that are really far away from each other conceptually, and there's still this like assumption that was being made there that ended up being incorrect. Originally when we went into the audit, I'm guilty of this. I know a lot of other people are guilty of this, but you go for the headshots. You're trying to find the most critical issue, and if you try to go into this with that approach, it's not going to be very good. It's not going to work very well for you. I don't know. Maybe you'll find something like the double reentrancy thing, but this one finding that we had, it was so subtle, and like these parts of the code base that were completely apart from each other is really cool. And I expect that if there's going to be other findings in this contest that aren't critical, it's going to be similar, where it's these two parts of the system that are really conceptually very, very far away from each other, but they're linked by like this one little bit, and there ends up being an assumption there that is broken.
Yeah, that one was a very cool finding. I think your Trail of Bits' core audit report was the last one we got back. So you were given some fairly well-audited code already, and that was just like, a really cool find of a way of manipulating balances between sync and settle. It was very interesting, that one. Kurt.
All right, I also got front run a bit by Sarah. I was going to talk about the, skipping of the unsubscribe call by manipulating the gas amount provided. So
I feel like she didn't really talk about
the
63/64 thing.
I can go into, I'll go into a little bit more detail about it. Right, so I think it's interesting because it's this example of trying to balance trade-offs, and the thing that's maybe maximally good for the user, where you just completely ignore any failure from the subscriber, is sort of maximally bad for the subscriber itself, because the user can just supply enough gas where the subscriber call will run out of gas, but the overall function finishes, just completely skipping that call. And so the fix was to put in this check to make sure there's enough gas left. Then there's this subtlety, because the EVM has this 63/64 rule to prevent like infinite recursion or infinite call stack depth. But even after you put that check in, it's still a little bit suboptimal, because now the subscriber has the right to waste a certain amount of the user's gas, even if they don't need all of it, because you're saying, okay, the user has to send at least this much gas to be able to give the subscriber. But if the subscriber only needs 1/10 of that, they can try to waste all of it to grief the user. So now you have this parameter that kind of needs to be set pretty carefully and tuned, and it might even need to be dynamic, because like your underlying execution environment can change on you, right? Fortunately, there haven't been a lot of hard forks lately that changed gas costs, but like back when I was developing at Maker, that was something like every few months, like, oh hey, the storage opcodes are changing in price again, and we have to rethink everything, or recheck our gas optimizations.
Yeah, I think both core and periphery have a gas limit for a specific call. In core, it's the setting of protocol fees. You'll see a very similar setup. They're actually different now. The design was, we want them to both work exactly the same. It's this idea that you have a call and you want to fetch some sort of external information or carry something out externally. But if that call fails, or that actor is malicious, the call still has to succeed. So it's this model, and we limit the gas to the call. And then even if the call fails, we continue onwards, so that that call can't revert the execution. And it's really hard. We've spent a lot of time talking about these, and I think it's one part of the code that I think it's a part of the code where we will never feel 100% content with the design, because of what you're saying of you have to protect the subscriber to a certain extent, And so you have to pass in, you have to do certain checks and you have to pass in a certain amount of gas, but then the user then has to, if you say, okay, any subscriber can use up to 100,000 gas on unsubscribe, then to protect the subscriber, the user has to send in more than that amount. But it means if a subscriber only actually needs 10,000 gas, the user has to send in 100,000 anyway, and the subscriber could then burn all of it, instead of the user just sending in as much as they're happy to spend on that. And I don't think there is a solution that we're 100% happy with. We've come to a middle ground, but
I mean, you could let like subscribers somehow provide the amount of gas they're willing to use, and then users could, you know, decide in the subscriber market which limits do I trust
look
more.
at Sarah's face.
Yeah, they're really not any like. I haven't found anything where I'm just like, oh, that's perfect. Everybody is protected, and there are no bad edge cases.
Right, and the future-proofing thing. So we had a model for a while, and we actually have this in core, I think, in our final design, where, and this actually came from someone at Opens Upland, Nikita, who was on our core audit, came up with this idea of saying, instead of passing in a hard-coded gas limit, to make it future-proof, you could just pass in you can give the external call a percentage of the block gas limit. And that means that external call can never use the entire block gas limit and prevent someone from carrying out this action. And they just have a hard-coded percentage, and that gives you more future-proofing, because if the gas costs start changing in future, let's say gas starts going up, but block gas also starts going up, that percentage like increases over time too. But I think we've ended up with that in core, but not in periphery, for various reasons. We've spent a long time talking about gas on external calls. One of our favorite topics. Have we spoken to everyone? I think so. Yeah. Are there any questions from the audience? I feel like, yeah.
In the process, do you have any engagement with the consensus mechanism, with the topology of the network, with the meme pools? Do you check failures on that level?
Generally not. You know, for the most part, when you're auditing smart contracts, you know, so long as the chain will come to consensus, you know, that's mostly what you care about. The one thing that you sometimes consider is eclipse attacks, right? So, and you know, the general defense for that is that a transaction needs to kind of fully encompass the user's economic intent, so that it can't be used or say like replayed in a different context. Like, because a classic eclipse attack, for anyone who's not familiar, right, is you know. The topology of the network means that you're connected to certain other nodes, and if you're surrounded by a malicious set of nodes, or you have malicious peers, they can kind of fool you into thinking that certain things have happened in one way, but they have actually happened in a different way, and you think something has happened, like you've sent a transaction in the context your malicious peers showed you, and then they take that, they replay it in the real world, and it does something you didn't want it to do, right? Like you said, you know, I want to buy, you know, I want to make a swap, you know, up to some slippage limit, and then it turns out that that slippage limit in a different context is, you know, very bad for you. Like, you know, like maybe you said I'm willing to swap up to a particular price, and you thought that price was close to the price of the pool, but in reality, it's very far. I don't recall seeing any issues with that while I was auditing the V4 code, but you know, I've definitely encountered that sort of thing in the past. And other.
I've got a thought. So all the stuff that you said, yes. One finding that we had that was kind of like, it's not really a flaw in the smart contracts at all, is that these hooks that you can attach to pools, you have to grind out the address to get the configuration right for those first couple of bits. And one thing we were thinking about is theoretically someone could grind out a hook address that looks just like another hook address. And so maybe there is a USDC ETH pool with a specific hook address, and everyone uses that pool for doing everything. Someone else grinds out a similar address, creates another pool, and tries to fraudulently get people to swap through that pool, maybe through like some kind of front-end attack or something. The question was, how would a wallet be able to inform someone that they're swapping through a malicious pool? And it's kind of still an open question. I think it's up to the wallet people to figure that out. So good luck to them. But yeah, sometimes you do look to those outer edges, but like once you get to like the consensus level stuff, you only care about MEV. Like you only care about what happens when something can be sandwiched, what if it can't be sandwiched or like backrun or whatever. For V4 core, like none of those assumptions are built in. Like you assume the periphery contract is going to take care of like, the limit stuff, like you said. And in terms of not getting sandwiched, other than the limit stuff, like it's just something that you can't really address at the smart contract level.
There was an issue on Open Zeppelin's core report where our response was, we'll fix this in periphery, where it's like, yes, that is theoretically true, and integrators should be careful to fix that, but it's up to the integrating contract. I can't even remember what the issue was. I just remember us saying, we'll fix it in periphery.
I think it may have been the front-running pool initialization issue.
Oh, yeah. It's one of your mediums. Sarah and I reel off, like, you know how people talk about EIPs, where we talk about 1155, like it's like a really common thing. Sarah and I are like that with audit issues now. We're like, oh yeah, Open Zeppelin H01, blah, 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 blah. We do that with all the audit reports. I know all the numbers.
On the subject of, if we want to include sandwiching here, which, semantics of whether that's a consensus layer thing or not, the donate function in core is actually very easily to sandwich with just-in-time liquidity. We kind of decided that was more of a problem for users of the donate function to solve rather than something that should be enforced in core, because there are many ways to solve it, like lockups on user positions, or gradually distributing rewards rather than doing it all in one big donation. But that is a tricky design consideration for hooks or anyone who wants to use the donate function. Very, very easy to sandwich, and you'll have to figure out your own solution for that. Now, you look at, like, say, ERC 4626 vault designs, they all have some sort of solution for this, variations on it. But yeah, that is a bit of a gotcha if you're going to use that function.
I believe you reported it as an issue, and we just added a comment.
Yeah, the fix was the fix was adding documentation, which honestly, like, I would have made the same decision as a developer, because it would add a lot of complexity to core, and you don't want to mandate the solution. But,
No, it's definitely something to be aware of. Nice. Any other questions? Yeah. Yes, many. If you look in the code base, by far the longest fuzz test we have is of that behavior. It's by far the longest fuzz test I've ever written, because there's so many different cases. So one that I briefly mentioned earlier is when the pool is running out of liquidity. If the pool is running out of liquidity and the hook doesn't have sufficient checks, the user can drain the hook. We've ended up concluding that one's okay. It's more that hook should obviously have checks in place, and this is a hook that's giving away money to the user. So let's say there's a hook that gives 100 USDC on every trade. If the pool only has 1 USDC of liquidity left to trade, and so the user says, I'm going to trade $1,000. The hook says, we'll give you another $100. So there's $1,100 going to be traded. Only $1 gets traded, and then whatever's left over gets credited to the user. So then $1,099 get credited to the user, even though the user only ever put in 1,000 at the beginning. If you're interested in more, I'd recommend looking at that fuzz test, because for a fuzz test, you have to specify all of these edge cases and basically acknowledge it and say what should happen and whose delta should be what at the end. And that had to be one of the cases of, like, if this very strange hook exists and they don't check that there's any liquidity in the pool, expect that the user gets all the hook's money. And we had to write that into the test. Did you guys have anything else around that? That was...
I mean, I would highlight from your answer that most of the risk is to the hooks, yes, rather than to users or to or to other pools, because of the way the delta accounting works. The hook is just on the hook, so to speak, for whatever modifications it wants to make, to the delta or whatever it wants to specify. And so, yeah, hook development and I guess hook audits are going to be quite tricky in the future.
Yeah, very tricky, I think. Yeah. Anyone else have anything around custom accounting? No. Nice. Any more questions? Yeah.
Just a question about rebasing tokens and build approving tokens. Is it like the same limitation as in free, so you cannot really supply without possible providers?
Yes, rebasing tokens are not supported directly in Uniswap v4. If a rebasing token rebases up, that interest is lost. And if it rebases down, then not everyone's going to be able to withdraw their liquidity because tokens have disappeared. Instead, we recommend wrapping the rebasing tokens. So for example, in V3, people trade wrapped stETH. What's nice about V4 is we have a proof of concept hook somewhere that does this. You can create a pool for the rebasing token that's essentially a ghost pool that doesn't have any liquidity in it, and you get the modify liquidity function to always revert. And then you can, in the hook, so if someone goes to swap, you can use custom accounting. Someone says, I want to buy one stETH, which is a rebasing token. The hook takes that stETH, wraps it, trades it behind the scenes on the wrapped stETH pool, and then funnels the output of the swap back to the user, and it looks to the user like they swapped on the rebasing token pool that actually doesn't exist. And it's behind the scenes trading it on a wrapped rebasing token. That might be, we have a proof of concept somewhere I can send you. Any other questions? Yeah?
It's not a question. It's more like a request. Because I feel like you've thought of everything. Formal verification, the differential testing, logical flows with the check-ins that see somewhere else, limits in the inputs, maximum values and everything, different curves that you can apply. Like, it feels like everyone has thought about everything. So, and losing time in rabbit holes is super important. So it would be so cool to have like a checklist of everything you have done. You know, if it's possible to create that, because that resource would be very useful to save a lot of time when you have to run the competition.
Mm-hmm.
So in the Trailbits audit report, there's a coverage section, and it says exactly what we looked at and how we looked for it. Yeah, so that we're covered. Yeah, yeah. All of you should look at all the audit reports and read them before you even look at the code. I forgot to mention this, but that's so important because you want to know what has already been reported, and you can get a good idea of what people have been looking at through like coverage sections or like when they describe the system. You want to get an idea of what they've already looked at because you don't want to duplicate their effort. You don't want to go and like formally verify that the V3 Solidity library equals the V4 Yule library because someone already did that. So it's really just trying to figure out what did other people look at and focusing on what they didn't look at.
Yeah, for example, what you said about checks in the Fitbit. 3 days ago, I was reading the code, I'm like, oh, the check is missing, where is it? And now you said it's like, okay, I'm not going to like thinking about it. So I'm like, thanks for saving me a few hours.
Nice.
No problem. I mean, make sure I'm right about that. Maybe there's an edge case. I don't know. But
Yeah, that's true.
I'd also say, first of all, Core has had more audits than Periphery. Core has had 5 audits, including formal verification. Periphery has 3 audits and no formal verification so far. And just because Core has been audited 5 times doesn't mean that all of the code has been audited 5 times. There are changes that have been made in the last week because of audit issues that came back. That means there's areas of the code that function differently now to how they did in any of the 5 audits. And so if you look at a diff of the code now to the code 2 months ago, 3 months ago, the areas that have changed the most, I would say probably have the highest risk of flaw. So in Core, Sarah talked about it earlier, but the number of times we have changed the sync and settle mechanism because I think every audit firm basically came to us with some problem in that mechanism somewhere. Diffs in that, and Periphery, I would say, is more likely to have a bad bug than Core, is my prediction, but maybe I'll be proven wrong.
Yeah, if I could add one more little bit to that. Earlier, you had asked us, what are we most like secure with in the code base? And we all mostly said like the V3 stuff. I mean, there you go. We mostly didn't look at the V3 stuff.
Oh, maybe there's bugs in that. Kidding.
I hope not.
I would also add that I agree, you should read all the reports and you'll get a sense on some patterns on where these bugs stem out. We mentioned a few sections, so I would also check the fixes for those issues. There were a lot of issues, a lot of rushing, and we had way more time to look at the code base than to look at the fixes. So of course we reviewed all the fixes properly, but I would focus on those. And also V4 has been out for over a year, but what everyone audited is quite different than what came out a year ago. So there were changes in the last 3 months. So obviously something that has 3 months of life is more prone to errors than something that's 1 year old. So I would focus on what those differences are and take a deeper look.
Definitely. And we even mentioned this internally, and then it ended up coming to get us. So if you get two audit reports back and you're fixing bugs from both of them, and then you're sending the fixes back to those audit firms aren't always aware of the bugs that the other audit firm found and how your fix from one might be affecting fixes from the other. And from our first set of audits, I'm going to remember this incorrectly probably, but there was 2 fixes we applied from 2 different audit firms, and we essentially introduced a new bug through those 2 together, and each of them independently reviewed the fix that they were given. And I think on day 1 of Spearbit's audit, someone was like, oh, because we gave you a commit like 2 days late. And so someone looked at the diff between what were we given on Monday and what's the commit now on Wednesday, the final commit. And someone was like, these 2 pull requests that have been merged have introduced the bug together. So whilst we've had all these audits and had all these fix reviews, like we've merged a bunch of audit fix improvements in the last week. And yeah, it makes me nervous that we could have done that again. Thankfully, the one we introduced wasn't bad. It came out as like an informational or a low or something, but it was like, it's proof that we're all human, and there's like a limit to what audits are capable of. They're an amazing tool for finding bugs, but they're not bulletproof, which is why we've had so many and why we're now having a competition. Yeah.
So if I could maybe synthesize the responses to the original question, which was, it'd be great to have a list of everything that's been looked at. I think rather than thinking about avoiding things that have been looked at, you should instead just be thinking, what are the highest probability places for there to be issues, which is going to be evidenced by what's had recent changes, what are the new mechanisms, what has less testing? Because I think at this point, a lot of things have been thought of. And so rather than being like, what should I avoid? It should be more, where should I be looking, because you can get a lot more clues about that.
When we do our report, we also have not only the bugs we found, but also the properties that we actually proved. And you get the list of properties. And if there is a bug fix, we can just rerun our tool. And sometimes you have to change it. If the settle mechanism changes, then you can't use your old properties again. But if you're lucky, you can just rerun it and it tells you there's a new bug here.
This actually happened. There were 2 issues in the Certora report that were closely connected to each other, and we fixed one and we hadn't fixed the other, and they ran their properties again, and we broke another formal verification rule because the fix to it was going to be to fix the other issue. I think the rules have now been run again on like a more recent commit, so things are looking good, but yeah. Hopefully that gives you some tips at least. Any more questions? Yeah?
Do you have any list of the properties in your report, you have some portion of the properties you actually proved?
Yeah, so in the report, we first give the bugs we found, and then we give all the properties we looked into and approve a result for them.
All the reports are on the repositories on GitHub.
And we usually also link to a website where you can look up the exact property, the source code basically for the tool.
Quick disclaimer on the reports, a couple of them, Spearbits in particular, are still in draft phase. So, the issue write-ups are probably all finalized, but in some cases we haven't fully reviewed the fixes yet, or the fix reviews might still be in progress. So that's maybe another place to like look for, where should I start as like, things that aren't already marked like verified. Maybe we haven't gotten to it yet. Maybe we missed something in the fix.
Yeah, I think 3 of the 5 audit firms that there still are in draft, and ABDK's report doesn't say we fixed any of the issues because they just haven't got around to reviewing our fixes yet. So it currently says that none of them have been fixed, and some of them obviously have. Sarah?
Was there any feature or maybe optimization or code change that you were like, dang, this is missing from the code? Or like you wish you would have seen?
So like things that, like if I were to write the code, what would I do differently? Oh,
Yeah, or maybe like if you have audited other AMMs or anything, like you like some kind of feature that before didn't have.
I feel this is a bit of a trap question because, like I said earlier, like I gave this example of the tick checking, right? Where like there was many things where I'm like, I would have rather just like put very clear upfront checks, so that you knew what assumptions you were working with, and like certain things weren't possible. But like I said, I think the code probably got to the state it did because of this like manic drive to optimize it and not have external libraries, introducing external calls. And so like under the same, like I didn't live for a year of development under the same incentive set. Right? And as a security auditor, I'm like, well, this is how I would write it to prioritize security over everything else. Right? But then you start saying, well, there's gas, there's feature richness. I still think maybe there could be a little bit more like explicit checks, or at least explicit like commenting of some of the subtle stuff. This is a common thing I see in many code bases of like, we will religiously like do nat spec for every function parameter you could have guessed the meaning of just by reading the name of it. But like this complicated multi-file interaction, you just kind of have to figure it out. So like if you look, for example, at like very low level code for like drivers or something, or just really like detailed stuff, a lot of times the comments are longer than the actual code. And that's something I'd like to see more of in general in these like very complex, very high stakes DeFi systems of like, like the actual justification for this one line is like 3 paragraphs that's right here. And like what all the other functions that interact with it are. So maybe that's what I'd say is assuming that the incentives have been balanced correctly, maybe just more explication in the code of this is why it works this way, even though it's like pretty weird.
Yeah, I know in particular, Solomon and Natalie from one of our Spearbit auditors made multiple requests like that. There was a long issue about proving that all of our unchecked blocks were safe, because we just didn't even have or some of them we'd have like a 1-line comment, or some of them there'd be no comment of saying why it was safe for the math to be unchecked. And so that was an issue brought up of just like, can you please, like we've checked that they are safe, but can you please comment why they're safe?
Yeah, that's an excellent example of this.
Yeah, if I could add something that you might change, you should have written the whole thing in Huff.
Oh God.
But like more realistically, as protocols try to do like more and more stuff and they try to be more and more optimized, there's this tendency to have to work around the Solidity compiler. And as a result of that, there's added complexity. You have to like drop into Yule and do stuff in there. Now you got to worry about, working in Yule. And it feels like we're starting to get to a point where everyone is trying to work around the compiler a little bit, especially with the slot 0 stuff. I saw that and I was like, oh yeah, the structure packing is a little bit of a problem. But I don't even think this is something that you guys could do. It's something I think the community has to address and start thinking about how we actually have to design these systems, because it is getting very, very complicated. And if the compiler was perfect, and no compiler is ever going to be perfect, I feel like a lot of the complexity could have been abstracted away or just ignored, and you'd have a more secure protocol because of it.
100%.
Building on top of what Kurt said about these non-explicit checks that end up being fully secure, I feel like that's some signature touch from Uniswap code. I've seen it in almost every project I've looked at. I remember from Uniswap X, there was one check where I lost a bunch of time. It was clearly wrong. It had to be wrong. It turns out it wasn't. It was very well thought out, and whoever coded it thought about every potential scenario and knew that could not happen. So that's a double-edged sword because first, either you go down a rabbit hole or you think, oh, these guys know what they're doing, so I'm not going to check it, and then you miss something. So yeah, I kind of like it, but it's also difficult to audit, yeah.
Yeah, and I think it means, like, obviously we've ported over a lot of logic from Uniswap v3 to Uniswap v4. Well, Sarah and I didn't write Uniswap v3, and so it gives us the same scaries of we're using this library that we didn't write, and so you then have to spend a lot of time digging into everything that library does and how it works to then feel happy using it again elsewhere in a different way.
I think this compromise between security and gas optimization, this is always a problem. The many places where you use inline assembly, and then you need to think about the dangers of inline assembly, that some parts of the words are uninitialized according to spec, but it may not occur with the current compiler version, but later maybe.
Yeah.
And on the other hand, this settle mechanism that was this new settle mechanism that was introduced for security also basically made some old use cases not feasible anymore. So you can't send multiple tokens at the same time.
Yeah. Once we've got more L2 use, we'll get rid of assembly use.
Is there a feature that you couldn't verifiably find an attack vector for, but to this day is it still bothering you, that you're still uncomfortable with, that if you were Uniswap's CTO, you would have vetoed that feature? You would have done it?
Wow, vetoing a feature.
I mean, your inner feeling about features, not.
That's a good question. I mean, because on the flip side, I see the power of a lot of the features, you know, like, for example, the hooks are terrifying, but that's kind of the whole point, right? Like, why are you even doing V4 if you're not going to have hooks? So, like, I don't think I would have vetoed hooks for sure. I don't know, maybe the subscriber feature, because that is something that could, in principle, be built on top. Like the advantages that it gets of having this like more trustless staking experience, you still have to have some degree of trust to the subscriber, because it can like veto, it can revert everything but unsubscribing, and that can be, you know, quite annoying and inconvenient. And, you know, like just a third-party staking contract can still be like formally verified and audited, and, you know, our staking contracts are, for better or for worse, you know, one of the most common types of code you see, and they're getting better all the time, and there are standards for them now and things like that. So maybe I would have looked at that and said, okay, nice in principle, but I don't think we strictly need it, and maybe we should put more energy, you know, into making sure other things are safe and secure and robust. But I don't know. I don't look at any big piece of the code and be like, yeah, just throw it out.
Are you actually asking, like, where do we think, like, where's the riskiest trade-off? Because that's kind of what it sounds like the question actually is.
Yes, what bothers you the most? I mean, if you could find a verifiable attack vector, I would have seen it in the report. But
yeah.
Is there something that you couldn't find an exploit for,
okay,
but it still bothers you internally?
I've got something that bothers me.
Oh, no.
But see, the thing is, this bothers Uniswap as well. So like, I don't know if I can really say it is that, but so transient storage is per transaction. It's not per call frame. So you could have someone lock the Uniswap core, do something, unlock it, do something, relock it, and then unlock it again, do more stuff and relock it. All that transient storage is going to be shared across all of that, because it's all the same transaction. And I hate that.
Right, because if there's anything left that's non-zero from the end of the first transaction, you
Yeah.
can't assume it's going to be zero at the beginning of the second one.
Drives me nuts.
Wow, I haven't heard that answer before. I like it. Except I don't like it.
This is interesting because at one point we were over the bytecode limit and we were talking about what we wanted to remove. And I think the first on the docket was 6909 functionality.
We actually wrote it at one point as not 6909 compatible, like way more minimal, no approvals, no, like it was just a mapping of like, this is what you own in core, because we were battling the 24,000 kilobyte, whatever it is, contract limit. Every time we compile the code, one of our gas snapshots, which we talked about earlier, tells us how big the contract is, and we're really at the borderline. I think it was one of the Spearbit issues. We wrote a fix. They checked that it was right. They put in their report that we'd fixed it, and I had to message them the day before the contest and say, I just thought you should know we didn't merge this pull request because it pushed us over the bytecode limit. So please can you mark that we have not fixed the issue? And it's like an informational issue, I think. It doesn't matter that it would have been nice to fix it, but yeah, we're on that limit. But I think 6909s were like one of the, if you had to remove something to save bytecode, we'd have removed that.
But also, it's not like a particularly scary
No, I don't
feature
think
either.
scary, no. Any more questions? No? Nice. Well, let's give a big thank you to these auditors. I think we've felt very lucky at Uniswap Labs and Foundation to have an amazing opportunity to work with so many top audit firms, and we've learned so much from all of the auditors and all the companies we've worked from, and yeah, and it's amazing. I think all 4 of you have flown in for today. Have you? Did you as well? Yeah? Yep. Just to be here for this panel, so yes, thank you so much for coming.
Thank you.
Thanks for having us.
I can handle it. Yeah. Don't worry about them. Okay. Thank you, though. Cool. So from now until 5 p.m., it's like a working session and networking. So obviously, take the opportunity to work on the competition, and obviously ask the Uniswap team any particular questions you might have. 5 o'clock, we've got dinner, which will be in the same spot that lunch was in. And there's still some food left in there as well if you're still peckish. But yeah, just wanted to say a big thank you while everyone's still in the room to the Uniswap team, Labs and Foundation for hosting today. It's been amazing so far, and for everyone coming as well. And obviously from Cantina's side, if you're a researcher and you haven't signed up yet for some unknown reason, do that. And if you're a client, obviously come have a chat with us as well if you're looking to get your code reviewed. But yeah, good luck, everyone. Thank you.